Yup. You're live.
Want to get chink talk?
Yeah, we can't. Don't. I don't want to get fucking. No, let us at least go on for 5 minutes before getting a warning for violations. All right, let me delete.
Me just stood there going chink talk, chink talk, chink talk.
Winnie the Pooh, dude. All right, cool. Let's see. Okay, go to the queue. Let's see what the first question is going to be. It's between oats and breasticles. 83% chance to 16. Ooh, let's see if you're shadow banned, breasticles. Let's check it out.
Let's go gambling!
Let's see.
Let's see, dude. What shall fate say today? Oh, dude, you are shadow banned!
Yeah, I guess I am.
Dang, dude. Oats won with a 16% chance. Oh, jeez, that's too funny. It's okay. All right, you'll definitely be next, unless like everyone else starts submitting questions right now, and then
You can't give them those ideas.
We can't give them those ideas.
Yeah, because now they're all gonna submit.
Yeah. Voting was rigged bigly, bro. Don't even get me started. Okay. For the circuit shown in the figure, the switch S is initially open, and the capacitor voltage is 80 volts. Oh, okay. So it's actually charged. Okay, cool. All right, so this is originally 80 volts, and then it's closed at time t equals 0. How long after closing the switch will the current in the resistor be 7 microamps? Okay, so we want to know I is going to be equal to 7 times 10 to the minus 6 amps. Yeah, this is cool. So this is charged, which means it probably already has like positive and negative charge on it. And what happens when you close this switch is these charges are gonna like try to annihilate each other.
Surprise, motherfucker!
They're gonna neutralize, and the way they neutralize is as they pass through this thing, this is gonna give off heat because it's a resistor. Resistor is like friction in electrical world. Okay, there's an equation for this, and I believe it's this. I believe it's that I is equal to I naught, and then I think it's 1 minus e to the e to the no wait. I want current to start out high and then go low. Okay, so I think it's this. I think it's e to the minus t over RC. I want to say it's this. Did I do it?
I believe so. You could verify if you set it up as a differential equation.
We could set it up as a differential equation. You're very right. Yeah, we could. Yeah, because
that's where it comes from.
Because I is the same thing as
accurate.
dq dt, right? Yeah. This is very cool. This is also a differential equation. I think how this works. So I'm gonna take a little side tour just to go into differential equation land. I think this comes from so Q, right, is equal to V over C for no.
I think it's V is Q over C.
Right, yeah, this is it. Q equals V times C. So, I think I want to do... No, I think I just want to leave it like this. And then we say that V, right, is equal to IR, right? So Q is equal to IRC. And then I... current can also be written as dq dt, right?
Yep.
Okay, great. Okay, so then I have Q over RC is equal to dq dt. Yes, and then this is a differential equation that you can solve by saying, let's pretend that Q is equal to, I think we say e to the AT. So dq dt is equal to a e to the AT. And then you plug it in just to kind of see if it solves. So that gets you e to the AT over RC is equal to a e to the AT. Aha. And then in order for these to match up, right, because this cancels and this cancels, we know that a has to equal 1 over RC. And so, this is true. We can say that Q is equal e to the 1 over RC times t, the same thing as T over RC. What's up, ABD? And then if you want to solve for dq/dt, right? dq/dt, which is current, that's going to be equal to 1 over RC e to the T over RC. And then I think what we do here is, yeah, we recognize from this. I guess if we're given R and C, we could have already. Were we given? Yeah, we were already given it. We could have figured it out. But another way to say this is I could. Man, how do I want to do? I want this to be I naught. Do you remember how we make this I naught? Do I do this? Do I divide it? Divide both sides by.
I'm trying to remember, but I was gonna. Mimi's on the right idea. That what I was gonna say is you could solve that as a separable differential equation or as using your integrating factors. And then once you've done that, you can just use your like boundary conditions and your initial conditions to say that your constant is going to be your initial current. Yeah, I see. Just kind of based off inspection.
Oh, I see.
You get this C and then it's exponentially.
Yeah, this is.
So
I got it.
First,
so
it's going to be your initial current.
This would be dq. The pretend thing put me off. Pretend? Yeah, sorry, not pretend. Sorry, not pretend. Assume. We say like assume a solution, right? Assume the solution. And I think we needed to put a negative in there, right? Because I need this to eventually become negative.
Yeah.
Yeah, right? I think we do this. I think we assume this is negative. So then this is negative. And that means A is equal to negative 1 over RC, so then it's this. And then if I want to solve this, right, I could move the dt over. And I get A e to the AT dt. Or e to the negative AT. Well, ooh! Wait a minute.
Well, that's just going to go
That's just going to cancel out.
What you had. If you wanted to solve it, you would start with your initial differential equation.
Which one?
Q over RC equals dq dt.
Yes. Oh, this one. Okay. Got you. Oh, and this one I want to integrate. Thank you. Yeah. Yeah, okay, yeah. You don't have to do this, actually. Sorry, I went down like kind of a rabbit hole. You can actually just solve this directly. Sorry, let's get rid of this. Let's get rid of all this. This is kind of cheating in DiffyQ when you say I already know the answer. Let me just make it fit. If we move the Q over there and the dt over here, yeah, this is what I want. So I get 1 over RC dt is equal to dq over q. Perfect. This is what I want. And then I integrate both sides. And then so this just becomes t over RC. And then this is going to become ln of q, right? And then, but then that's plus c naught, right? Plus c.
Mm-hmm.
So now, when I solve for q by doing e to the, I get e to the t over RC is equal to e to the ln of q, e to the c. This is the same thing as just c. Nice. So then I say that e to the t over RC is equal to c, c times q. Okay. And then I have to make the condition that at t equals 0, q needs to equal q naught. Has to equal the initial charge. So when t equals 0, this becomes 1. And then so you get, okay, so 1 is equal to c q naught. I'm in grade 6. What the hell is this?
Oh, no. Well, that's a lie.
Yeah. the potato, very good potato. Can you count the potato? Man, but I still want I still want the minus sign though, breasticles, right?
Yeah, I'm trying to think.
Why am I not picking up the minus sign? Q equals
let's
V.
play a game.
It's got to be it's something minor because if you were to say move your subtract the Q over RC and then use an integrating factor, you
Yeah.
should get that negative.
dq/dt needs to be minus. Interesting. Current has to be negative? I wonder why that is. I get that it is decreasing. I'm just trying to think from this point of view. I guess the potential is flipped. It's something about like the potential across the capacitor. Okay, but if that's minus, what does what say, sir?
dq/dt needs to be minus. I mean negative.
Yeah. So instead of saying Q over RC equals dq/dt, I say Q over RC is equal to negative dq/dt. Because, and I agree with what Bimi's saying, is that the current, right, because this is I, this is negative I, the current needs to be decreasing.
Oh, right.
Or the charge needs to be decreasing. Yeah. My favorite part is there is no ChatGPT when trying to solve this differential equation. I mean, honestly, ChatGPT probably could like figure out my error really quickly here. I'm just not letting it. But anyways, okay. Assume that's that. Then I at least get this, right? I get Q naught. So, does that say C is equal to 1 over Q naught then, no? Or I guess it doesn't matter where you put the... This is so complicated. Why are there letters in math?
Oh, no.
Yo, it's okay, buddy. It's okay, dog. Why are there numbers in math? Wait, because couldn't I put the C over here as well? And
Yeah,
then that
you
would
can
be
put Q wherever
C.
you want.
I could put wherever I want, right? If I do this, then I get what I want. I'm just curious why I don't get it the other way if I put C on the other place.
Why didn't you just reverse this?
Yeah.
Did you just move plus C from one side to the other?
That's all I did. Yeah, because it's a constant. So you can either like add the constant here, add the constant here. You're still just gonna solve for it. Whatever. Right. T equals 0. Q equals Q
Wait, how is
naught.
that not?
It's because in integration, right? So when I'm integrating, these are both plus like an arbitrary constant is what it is. That's what happens when you integrate something. The reason being is if you had a bunch of lines, for instance here, integration is called the antiderivative because what it does is I'm trying to put this into words. All of these lines have the same derivative. This f prime is equal to this g prime is equal to this c prime, but they have very different areas if I were to add up the area underneath them, right? This would have more area, this would have less area, but the difference in the amount of area they have is a constant. It's a vertical shift. These are just shifted vertically up and down. So when you do an integral and you're not told the bounds, you have to add this arbitrary constant because it could be this derivative, or it could be this line, or it could be this line, or it could be this line. Yeah, and
after the integration.
Good. Yeah, exactly. Yeah. Because okay, here's what happens: when you take the integral of a derivative, you get the original function. Okay. These are 3 different functions, right? So this is f here does not equal g, and it does not equal c. But all of these derivatives are the same. So if I integrate the same thing, I would then technically have to get the same result, but I don't. So the difference is it's this plus a constant. So these lines only differ by an additive constant up and down. It turns out that like bounds end up fixing this problem, but what we say is that like you could do plus c here, which could be the same thing as like plus 5, or you could say like plus 3 negative 2.
Well, yeah,
it's the same. Yes, it's a constant. You can always just absorb it into itself. They call it collapsing. Yeah. So in the case of that,
my initial confusion.
Yeah. What's up?
Sorry, my initial confusion was if you move something from one. Generally speaking, you move something from one side of an equation to another.
It has to be a minus sign.
You have to make it equal 0.
Yeah. No, I agree.
You know
I
what
agree.
mean?
Yeah. The difference here is when you have two integrals on each side, they both pop out constants. So instead of putting a C1 and a C2 here, I could just move this over to call it like C1 minus C2 minus C1, and then I can turn this whole thing into another constant, let's say like C total. And so now
Right,
I only
but
have one constant I have to deal with.
Yeah, because C is a constant now. So why is
Yeah.
C2 and C1 necessary? Why not just C squared or 2C?
Could be whatever. Yeah, no, you can set it to whatever, but what happens is you then apply what's called this is called applying boundary conditions. So most integrals have bounds where they have like a start and a finish. Boundary conditions is where you're going to plug in values for one of the variables and values for the other variable, and that'll tell you what the C variable needs to be. So at this point, I wanted to solve for Q. So I'm going to do e to the for the whole thing, and then e to the. So that's going to give me... So e to the a plus b is the same thing as e to the a times e to the b. So technically doing e to the whole thing here becomes e to the c, and then this is, all like this. But then this is another absorption thing here, is that e to the c is still a constant, so I can just rewrite this whole thing as just another constant. I can just absorb that just e to the whatever's happening. It's still not changing. And then here, you say, okay, when the time is 0, so when t is equal to 0, charge needs to be initial charge. So you get c e to the 0 over rc is equal to q naught. E to the 0 is just 1, and then that tells you that c is equal to q naught. So now in your final thing here you can say that q is equal to q naught e to the negative t over rc. And then whoever DMS is, the answer to your question is complete the square. Oh, okay, cool. Yeah. All right, anyways. So sorry. This is how you get the original equation for Q. And then I think you do dq dt, which is equal to current. And then that would pull down negative q naught over rc, e to the negative t over rc. And then q over c is the same thing as v. So this is I is equal to negative v naught over r, e to the negative t over rc. And then because v equals ir, that means that v over r is equal to I. So now this becomes I is equal to I naught e to the negative t over rc. But then we have another minus sign. I don't know, whatever. And this doesn't fucking matter. Okay. All right, I'm going to stop. Anyways, that's where it comes from.
Yeah, but you can absorb the minus into the I naught as well.
Sure. Yeah, just make it go away.
Oh no.
All right, yeah. So, again, sorry to make that a little bit complicated for you, Oates. I just wanted to show you where it all comes from, all the calculus. But, yeah, you don't need to know all that. That's just kind of fun to see, like, the underground. This is why math is important. This is why physics is built on math. This is all you need to know. And then what you learn is that V naught is equal to I naught R. And so if you want to get at I naught from this, I naught's equal to V naught over R. And so that's going to be the voltage on the capacitor, which is 80, divided by the resistance, which is 2.8 times 10 to the 6. Okay. So let's plug that in. So I'm going to get I is equal to 80 over 2.8 times 10 to the 6, e to the negative t, and then this is over RC, so 2.8. Actually, let me solve for t first. Sorry, let me make life easy, because otherwise we're going to just write a bunch of numbers in.
Oh no.
That sucks. We were trying to solve for the time. Okay. Solving for time. This is in the exponent. The way we know to get things out of exponents is to use logs. So the first thing I'm going to do is I'm going to move this over. So I'm going to get I over I naught is equal to e to the negative t over rc. Then I'm going to take the natural log of both sides. Okay. And what that's going to do is that's going to pull down this. So then I have...
We could also grab it from when we first solved our differential equation, when we did our first integration.
Oh, you're saying we could have pulled... Where? Sorry. Oh,
when we
from...
have C plus
Oh, this.
T over
Yeah,
RC
yeah, yeah,
equals
yeah,
L
yeah,
out
yeah.
of Q.
Yeah, but we're not really given Q. We're given V, I guess, and then we are given C, so we could figure out Q, but let's just leave it like this. You're right.
Sure.
It's all self-consistent. So this is negative T over RC. So then the next thing to do is take this and put it up. So this is going to be RC, and then we're just going to put a minus T there. And then you're done. Okay. So then the last thing to do is to plug in for the values. So that's negative 2.8 times 10 to the 6. This is where things are nice, because the capacitance, I think, is times 10 to the minus 6, maybe? Did they give us? Yeah. The capacitance is 22 times 10 to the minus 6. So here's the cool thing. The 10 to the 6 and the 10 to the minus 6 cancel. So I don't even need to, like, deal with this. Let's get rid of it. And then you have the ln of I. So I in this case is 7 times 10 to the minus 6. And then the initial current, which is this, and that's going to be 80 over 2.8 times 10 to the 6. And then that's going to equal our time. Cool. Let me go pull up the calculator. I'll get an answer for you. It's a fun question. I love circuits, dude. That's really what got me into my PhD, doing like plasma physics and stuff. Is I just love circuits. I think circuits are so cool. But I didn't like circuits enough to compete with Indian, electrical engineer people. I didn't want to get that hardcore. I was like, no, I'm cool just doing it as a hobby. And that's what you do in plasma physics. You kind of get like a soft EE degree along the way. Yeah, they are pretty cracked. Yeah. No, I just know the double E majors, dude. They're a different breed. Yeah, and I can't keep up with that. Yeah. I need a little bit more like practical hands-on stuff. Versus, dude, all the the Thenevin stuff. Someone was asking about op amps the other day. That stuff gets me nightmares. I just don't want to do it. Okay, so that got me 1.4 seconds, which is none of the answers.
Oh no.
Did it ever? You gotta multiply them. So it should be the negative 61.6.
Oh no.
7.4.
Yeah, thank you. Yeah, sorry. Yeah, I did these two separately. This is a calculator mistake. Okay, so this times... Oh, no, come back here, calculator, please. Thank you. This times this gets us 86 seconds. 86.6 seconds. Is that any of the answer choices? Yeah, cool. 87. Nice. Great. Good job, Oates. Did I ever have imposter syndrome? Yes, all the time. It's super, super natural. So yeah, especially, I don't know. I was decently up in my class. It's the whole like big fish in a small pond, but then you go to the big pond and you're like suddenly a small fish. Like I had a lot of confidence in myself in high school because I was top 3% of my class. I was pretty smart. I dunked on people, and then you get to college and now you're competing with everyone else who was like top 3% of their class, and suddenly you're like bottom 50% of the class. So and then you go to grad school, which is another like, dude, the triangle just keeps getting smaller and smaller until I'm straight up taking tests with quantum gravity geniuses, and like, dude, I feel stupid.
Oh no.
But yeah, it's.
Do you want to feel stupid?
Stupid is relative, right?
I know a way to make everybody feel stupid. I know ways to make myself feel stupid. Right? There's a TV program called University Challenge.
University Challenge. All right,
I don't know if you've ever heard of this.
Is it safe? Can you send me a link? Can we watch it?
Is it safe? Yeah, it's like primetime TV. Has been for like 40, 50, 60 years.
I thought you were gonna say something like Love Island. Like that show does make me feel like
it's a quiz
I'm smart.
show.
Oh, it's a quiz show. Okay.
It's basically a quiz show, but it's like they take university students from particular houses.
Okay. And do they ask them like
and
basic
then-
questions like point to Australia on a map or something and they can't do it?
No, it's like here's a map of this particular part of Australia, and like it's like really zoomed in. Which part is it exactly? And then and name that river kind of stuff. It's
Oh, okay, that's cool.
it's proper mental. It makes me feel like an idiot.
Yeah, I see.
When I
People-
want to feel smart, I
Yep.
tutor college algebra students.
Oh
That's my go-to.
Yeah. College algebra. Oates. By the way, Oates, are you in our Discord, Oates? I forget, but if you are or you aren't, your questions here in the in the homework help forum, and if you have an account here, I can give you points. Yeah, there you go, Oates 209. There you go, you get a point. Congrats. You're now at 2 bond coins, Oates. Congratulations. When you get 10, we'll buy you a gift card for like whatever gaming stuff you want. Jeff says, when I want to feel smart, I watch Dr. Gold do math. Oh man, dude. Jeff, waking up,
You can't
choosing
let them know
violence.
my secrets, Jeff.
Jeff, dude, what? Yeah. That's why Breasticles is watching the stream to just feel better about himself.
Oh no.
Okay. Yes, I can see this, Bobby. I didn't take high school seriously, and now I'm studying engineering. All good. Yeah, I didn't really take high school seriously either because I was just naturally good at it. And then I started to really try to like scrape by in college, and then I got to grad school, and yeah, that's when you hit the wall. You're like, oh, I can't just scrape by with my natural intelligence anymore because it's getting tested.
Okay. Here,
Where you
put this on a small screen.
Put this on a small screen. Okay.
Just two.
Just make it tiny.
Chevy trucks bring big
Make it
top
tiny?
power,
Just so you get a
so
feel
you
of
have
it.
choices for every job.
All right, here we're gonna make it tiny.
This
So-
incredible mold
Dude,
remover
how many
gel
ads
can
do I have for
restore
this,
your
dude? Oh my
bathroom
God.
and tiles
Who
to
wants to
their
get me-
original shine in just 15
I have to
minutes.
actually just put it on the full
This
thing. Apparently.
incredible
Okay, there we go.
Glory. Here we go then.
Use
Here's
the
your
fucking
first start for 10. Good luck.
All right, let's see.
By a resolution of the 20th of December 2024, the royal house of which country officially changed its coat of arms?
Ooh.
The inner scutcheon contains the 2 bars of the dynasty's parent house, the House of Oldenburg, while the shield is divided...
Darwin White, Denmark.
It is Denmark, yes.
Dude, who knows this information, dude? What? The coat of arms for Denmark? I have no clue about that.
So yeah, and these are general questions. These aren't the special questions, the specific questions.
Wow.
It just gets more and more mental.
Yeah. I get it. No, that's cool. I mean, some people have like insane recall on like random facts, which is dope. That's what Jeopardy is. And we'll see that this Saturday. We're going to see it. Bobby says, any tips for physics when there starts being like 500 formulas? Before I could know them all, now I'm lost. Yeah, no, that's a common thing.
Yeah. Yeah, you have to learn them all.
Well, you should be given some sort of formula sheet. I know certain professors that don't, which...
Oh
I don't know. I get sometimes their reasoning behind it, but the best way to remember all those formulas is to use all those formulas. I always like to say, you remember your first name, right? You remember all the names of your friends. And, why is that? It's because you've spent time having to remember their names, and it's kind of committed to memory. So yeah. Also in physics, when they say like 500 formulas, you could condense that down to a lot less, because one formula can easily derive probably like a bunch of other formulas if you forget them. So all you really need to know are like the core formulas, and then from that you can, if you forget the other ones, you can always like rederive them on the fly. I'm doing E&M, and there's so much stuff. Yeah, I mean, technically everything in E&M can be derived from Maxwell's equations.
Yeah, I was gonna say you can just,
Yeah,
you
right.
can just figure it all out from Maxwell.
You could, but sometimes I get it. Like an exam is timed. You don't have all the time in the world to start rederiving stuff. Jeff's right. Yep, that derives all the equations of motion. For E&M, yeah, I get it, because there's like the curl, there's the divergence, there's the what is it? Gauss's law, and I don't know. There's a bunch of stuff. Lenz's law, all the magnet stuff. Yeah, that stuff you have to kind of just get from experience, from doing practice questions. In general, right? I mean, this is kind of like all you need for E&M. It's like E dot dA is equal to like Q enclosed over epsilon naught. And then integral of B dot dl is equal to mu naught I. I feel like this covers a lot of just E and M, if you can do this. And then, I don't know, the basic like F is equal to QE, which from this, right, you can start deriving the equations for potential. You know, like potential is the same thing as like work, right? So that's integral of like force times distance. So the same thing as like QE dot dx. And then this is how eventually you get the potential is like KQ over R. So, you know, like, you know, E for a point charge is usually pretty good, right? Q1 over R squared. But even this, right? This technically comes from this, if you had to rederive it. And then you can get the potential is equal to KQ over R. And then, again, that one comes from this. Maybe it's E dot dl is equal to potential. I forget how it is. E dot dr maybe? E dot dr is equal to potential. And then this also comes from F is equal to negative grad U. And like electric force is QE. And that's equal to negative KQ over R. So then this is like DDR. And this is how you can also derive that, right? E is equal to KQQ over R squared. It's cool. Like, everything's like self-consistent. But the only reason I know all those things at the top of my head is because I've been doing it for 15 years. And I've seen so many questions. So for yourself learning it for the first time, Bobby, you could drill deriving formulas, but more than anything, I would just do a lot of practice questions. And that'll help you commit it. There's no shortcut for the work. You got to do the work. Okay.
Ironically, I passed both AP Physics C exams.
Yeah.
And I didn't do a single homework assignment in the 2.5 years of physics I had to take that course.
Oh my God. You passed, like you got a 3 or you got a 5?
3.
Okay.
But that's still credit.
That is passing. It is passing. I'll give it to you.
Oh, yeah.
Impressive. Yeah, but Bresticles has a very strong knowledge of math. And if you're very comfortable with doing math things, you can rederive all the physics stuff if you really want to. I mean, that's how they kind of did it. Okay. Let's go choose a winner. Who we got?
Let's go gambling!
Is Bresticle still shadow banned? We shall see. Not today. Okay, Bresticles, what you got for me?
This one's a fun one.
Aw, dang it.
Convergence of distributions. Wow. Is this like some real analysis we're gonna do? What's up?
This is, I figure it's probably part analysis, but this is actually the start, kind of like the foundational information behind Green's functions.
These are words that I've heard of, but I don't think I've dealt with them.
TikTok's gone
Yeah,
fine.
Green's functions being the right when you have a non-homogeneous.
Oh, it's not coming
either
through,
ODE or
Sensation?
PDE.
No, that's what I'm seeing.
You're seeing me tripled? Yo, what? Yo, what? Who's talking about this?
That's a direct screenshot. That's what I'm seeing.
You're seeing this? Triple Dr. Golds? Yo, what the hell? One sec. Let me go check this out. Let me go check this out. No, looks okay on my side. Is there a way for me to?
I think that's.
Are you in vertical mode?
TikTok. It looks. Yeah, I think that's TikTok.
Oh, that's you on TikTok, Sensation. Yeah.
Yeah.
Oh, okay. I guess that's what they do to. Maybe TikTok rolled out dual format, and they haven't told me about it. Cause yeah, I don't know anyone that uses the desktop version of TikTok. Really, it's all mobile. Y'all tell me in TikTok in if it looks good on your end. Okay, I don't know what's going on. But that's cool. That's cool, Sensation. I'll check it out. I think there is a dual format mode now. I'm just gonna have to like set it up again. Yeah. Okay. All right. Let's see. Let's do this one. Convergence of distributions. Distributions, U sub n, are a subset of D prime. of real. They
yeah,
converge.
so that's a distribution space of R.
Oh, Jesus. Okay. All right. Warning to anyone who's watching this. Like, don't worry if you don't understand it, because I don't understand it either. But Breskles is going to walk us through it. Okay. Okay. Distributions U converge weakly to UX as n goes to infinity for, I believe this is there exists. Is that what that means?
Yeah, for any phi, where phi is a test function on our continuously differentiable functions.
Thanks, Mimi.
R.
Oh my god, dude. I feel like dude, this is the bad acid trip I'm talking about. Okay. UN phi goes
if you read the question D, that's really where the bad acid trip like gets you.
Yeah, it just really starts hitting me. It's when the snozzberries start tasting like snozzberries. Okay. Let's maybe do like part A. Let's see if we can explain part A. This looks like gobbledygook to me, man, dude. This might as well be written in Chinese. What subject is this? Yeah, that's a good question. Chat's asking, what subject is this?
This is a partial differential equations. This is kind of the foundational information you need to know for Green's functions, which I guess is also technically ODEs.
I've done Green's theorem for sure. What's up, Rex? I don't know about Green's functions. I've heard the name.
So it's like for example, the Poisson equation. Like if you wanted to figure out electric potential given your boundary conditions, but you have a charge enclosed, right? Like if you remember in E&M doing the
was it this?
with
Is
separation
this where
of
this
variables.
phi is equal to like Q enclosed? Is this kind of what it is? Something like this.
Something like that. Green's functions originally popped up because he was working with the Poisson equation, trying to figure out stuff with a point charge. And the whole idea of a Green's function is that you can basically solve a non-homogeneous differential equation by taking a distribution and then doing the convolution with your fundamental solution, and then that gives you your particular solution.
I see. Okay. So it's it's similar to when we have something weird and we take a transform, or we do like an FFT or a Laplace thing, and then it's in a nicer space, and then we're gonna put it back.
Yeah, kind of. The idea is that if we were able to figure out what our derivative operator is, we can then figure out what the inverse of our derivative operator is, right? You would say, for example, with the Poisson equation, our derivative operator, or our operator, is a Laplacian.
Yeah, this is a Laplacian.
Right. Yeah. So we could write that as L operating on U. And then the idea is, well, if we can figure out what L inverse is, then L inverse acting on our f of x being our source term gives us U.
Okay, I see. Yeah, okay. So it's cool how, like, you can distill this to 6th grade level. For instance, if you had, I don't know, like 5x is equal to 10, and you wanted to figure out what this was, what you're doing is you're acting the inverse thing on both sides. So 5 inverse acting on 5, which 5 inverse is the same thing as 1 over 5. Acting on 5, these things cancel. And then you're left with, x is equal to 1/5 times 10, which is equal to 2. This is like basic algebra, but you can do this for even bigger structures like functions and distributions, where if, for instance, L is an operator acting on U, the same way 5 acts on x by multiplying, L acts on U by doing something else that's a little bit more complicated than multiplying, and has some answer f. If you can determine what L inverse is, which is similar to the divide by 5 or multiply by 1/5, this cancels this out, and then you can figure out what your original U thing was. Okay. So anyways, yeah, let's do a little bit of this, and then Shush is like skip.
Oh no.
No, we'll do some of this, and then yes, and then Shush, don't worry, we'll help you for your calc test. Okay, let's try to do part A.
I think. Well, I was gonna say C and D would probably be a bit easier, make more sense.
All right, let's do C then. Let's do C.
Because A and B are the more
Yeah, these are more like heavy proof things that like I'm just not gonna understand.
type of proof thing. Well, it's not that you wouldn't understand it. It's just like it gives you a kind of abstract proof of it. But I think C and D kind of give a better understanding of how the distribution space is different from real space, right? Because obviously k squared sine of kx as k goes to infinity doesn't converge as k goes to infinity in a standard space, but it does in this distribution space.
Okay. All right. Sine kx, when you act the derivative operator on it, gives you 0 as k goes to infinity.
No, that's not the derivative operator. That's saying in the distribution space.
Okay, in the distribution space of d prime, that goes to 0 as k goes to infinity.
Screenshot, but in the beginning of the chapter, they define right that d prime of r is a distribution space of the real numbers.
Okay. And then integrating by parts, we obtain. This looks like Brockett notation to me.
Yeah, that's
right. We do this in quantum.
Inner product.
Yeah. We do this in quantum a lot. This is called like Brockett. But okay, so I'm gonna say integral of sine kx dotted with phi of x is equal to the same thing as the integral of cosine of kx over k of x, which goes to 0. Oh, as k goes to infinity. I understand that, right? Because if this goes to infinity, dividing by infinity goes to 0. Okay.
Yeah.
So I see what we're gonna do here. So this looks very complicated, but they gave us a big hint here. They said integration by parts. So for y'all watching calculus, yeah, if you have a test, you probably need to do this. This is gonna be called integration by parts. And so what I'm gonna do is I'm gonna say that u is equal to phi x. So that means du is equal to phi prime of x dx. And then I'm gonna, well, sorry, I always forget to put the dx things. Yeah, that's my bad. Which actually, wait, did they did put it. Okay. And then I can say that this part right here, I can say that v is equal to sine kx dx, or that's dv, sorry. So then v is the integral of this, and the integral of sine is negative cosine. But then there's a kind of a u sub, which I call like backwards chain rule. And so this is going to be 1 over k, negative 1 over k, cosine of kx. Okay. So then what we get is, from integration by parts, it's uv minus integral of v du. And so uv is going to be negative 5x, and then we're going to say times all this. Oh, so okay. I see as k goes to 0, that's going to go to 0. Okay. And then it's minus the integral of v, which is this, and then du is going to be phi prime of x dx. Okay. Interesting. They didn't have this part still in it though, Breasticles.
So that's what happens is so they do it a bit differently, using some properties of the inner product by saying that cosine of kx prime is negative k sine of kx.
Okay.
But and then they would write it as the integral of negative cosine of kx prime phi of x dx, but your process seems correct as well.
Okay.
But what happens is we say that phi has what's called compact support. So that boundary term disappears.
Compact support. What the fuck does compact support mean?
So the way we define that test function is to say that on a boundary from A to B, anything that's not A to B is 0.
Oh, okay. So, it's kind of like a Dirac delta function, maybe?
In essence, yeah. Just
Okay.
it's not specifically one, but
I see. So when we do our bounds here, it's basically 0 everywhere. So that's why this goes away.
kind of. Our bounds would be from A to B
Gotcha.
because we have compact support. Everything from negative infinity to A, and then from B to infinity is going to be 0. And then when we evaluate our boundaries, right, at B and A, they both become 0.
I see. I got you. Okay, so that goes away. So then you're left with this, which is what we wanted. And then yes, the limit as k approaches infinity is this is going to be equal to 0 because you're dividing by infinity. This oscillates, and I think we assume that this is finite.
Yeah, what we can also do is we can use what's called the Riemann-Lebesgue lemma,
Ooh, okay.
which states that the Fourier oscillations of a integrable function vanish at a high frequency.
Okay.
And then, so that would basically say that the integral on R of f of x e to the negative I omega x dx goes to infinity as omega x, or not goes to infinity, goes to 0.
Goes to 0.
As
x goes to infinity.
omega goes to infinity.
Yeah.
As the frequency gets really high, it goes to 0. And in doing so, we can use Euler's formula to expand it and say that, okay, our real part is going to go to 0, and our imaginary part's going to go to 0 if the entire thing is equal to 0.
I see.
And then
Yeah,
so we
cosine
can
phi sine
recognize that cosine of kx, and k would be our frequency in this case. K is going to infinity, therefore the entire integral vanishes to 0.
I see. Yeah, because it would look like e to the negative I omega x or something. F of x. Yeah. And as x goes to infinity, this basically goes to 0. Okay, cool. Analogously, show that k squared sine kx. Wait. There's no integral on this, no?
Yeah, but we would do it in the same way. Right,
Oh, so it's
that
a
we
double
would-
integration by parts?
Yeah, we would set it up the same way using our
I see.
inner product.
So you would say k squared sine kx phi x, right? And then integrate this dx. Oh, fascinating. So wait, you'd have to do this twice because I eventually want this to match up or something, right?
Yeah, kind of. And I guess I also forgot there's that screenshot in there as well. But we do have a property of the inner product in our distribution space that allows us to basically swap around those derivatives, which is what we did with that what's it called, that compact support. So they did it by saying that sine of kx double prime is negative k squared sine of x.
Yeah. And
then from there you can just move that double prime over from the sine of kx to the or make it 5.
Oh, I see what you're saying. Okay. So let's just say if g of x is equal to sine kx, then g prime is equal to k cosine kx. So then g double prime is equal to k squared, negative k squared sine kx. And so you're going to say that this whole part here is negative g double prime?
Mm-hmm.
Are you allowed to put the k on the outside? I guess so. I mean, k is technically a constant. Yeah, actually, that's a good question.
You can, but
So wait, can't you just do this whole
can,
fucking?
it just-
Can't you just whole thing and just keep the K-squared out? oh! You know why that's an
kind
issue
of,
though?
It's
Bimmy, that's an issue because K goes to infinity. We don't want infinity multiplying by things.
yeah, it gets problematic in the space we're working in. and all
Okay.
that to
So then
work
I
that
have
way.
this, right? And you're saying I can transfer this second derivative over to here?
Yeah, in essence, it's kind of the same way we did it with the last problem. As you have that compact support and you integrate by parts.
Mm-hmm.
Let me see exactly what the theorem or the remark is. It says we can do it in the book, but
Alright. Go check out. Meshka says, I have questions. You have questions. We got answers, Meshka. Meshika Pereira? Yeah, here you go. If you want to submit a question, there's a link there to the website, and it's very easy. Just go through, upload, type in a username, type in a screenshot, and then upload, and it should work. Yeah, then there's the link for you. Okay. All right. Let's see. Do you have any other comments about this Practicals? I think this is pretty cool.
not off the top of my head, no.
Okay, cool. Thanks, man. This is fun. It looked really scary at first, and I know there's like a lot of stuff you're like not exposing me to, so I don't absolutely freak out. But it is cool to get acquainted with it, and I am glad that we're able to use, you know, calculus 1 concepts to solve things. It's pretty fun.
Yeah, for the most part.
We're big fans of that.
Some of it gets funky, but
Some of it gets kind of weird. This is in physics we call this like hand waving. You start waving your hand. You're like, "Hi guys."
Oh no.
All right.
yeah, pretty much. Honestly, even like when you have to use distributions, I haven't seen it need to get that deep, but
All right, let's see. Ooh, a lot of questions today. All right, let's go choose a winner. Who's it gonna be?
Let's go gambling!
Oats.
Good job!
Nice. Ooh, there we go. Electric E&M stuff. Yeah, Oats, you've won twice today. I'll allow it because I do like your question. Yeah, your lucky day. Usually pineapples are lucky cat. Okay, uniform magnetic field of 0.8 Tesla in the negative z direction is present. Okay, so they're saying positive z, so this means like out of the page. So positive z is into the page. Good, that's why they have the x's. I always like to think about it like if you have an arrow, right? If you were looking at the arrow, you would see the crosshair of the arrow going in. But if you were looking at the arrow coming out at you, you would see a dot. That's where it comes from. What I have extras here is, yeah, okay. Yeah, I got you. Yeah, so the key thing here is that I hat is just equal to the x direction, or x hat. And then j hat is equal to y hat. And then k hat is equal to z hat. The reason why we use I, j, and k is because x, y, and z come up as other variables to describe the magnitude of things. And so we don't want to have like x hat. That's like really confusing. That's why they use I, j, k. I just kidding. A uniform electric field is also present, okay. An electron is projected with an initial velocity of this in the positive x direction, and it passes through the region without deflection. What is the electric field? Okay, so if this thing moves this way, and it's not deflected, that means we need the force from the magnetic field and the force from the electric field to kind of like cancel each other out. And so what you learn, and I forget the name of this equation. I want to say it's Lorentz. Is it Lorentz? F equals QE plus Q V cross B is what it is. Okay. And if something is not deflected, that means the force needs to be 0. Right? So the net force on the object, which is equal to the mass times acceleration, that all needs to be equal to 0. Okay, so a couple things here. Yeah, this is going to be a left-hand rule because technically it's an electron, right? Yeah. This is so you use your right hand when you're dealing with positive things. You use your left hand when you're dealing with negative things, or that would come up here as well. So let's not worry about the direction of things first. Let's get just what the number is, and then I'll help you figure out the direction. So you need this to be equal to this, and in opposite directions. So let's figure out what QE would be. So I have that QE. I'm just going to do magnitudes. Needs to equal to QVB. Yes, exactly, because the electron. The Q goes away, and so I get that E is just needs to equal V times B. V is the velocity, and B is the magnetic field strength. And so the velocity, they said, was 9.1 times 10 to the 4. And then here, I'll help you with the direction in a second. And then B is 0.8 times 0.8. Okay, cool. So, yeah. I mean, just looking at this, I know 8 times 9 is 72. So this is going to be like 0.72 times 10 to the 4, which is the same thing as 7.2 times 10 to the 3, which is the same thing as 7.2 kilovolts. So which one has, or 72, not, no, yeah, sorry, I wrote this wrong, sorry. 0.8 times 9 is 7.2, and then you move it over. There you go, 72. There's a guy from your chat submitting different questions from 10 devices, is there? Oh. It's supposed to, no, these are all different. These look pretty different to me. Well, maybe not. You can submit multiple questions, but there's a timer. There's like a time limit. You can only do it every 30 seconds. If yes, people start abusing it, then I'm gonna have to up that timer to like 5 or 10 minutes. But it's always a learning thing. We figure it out. Okay, so yeah, that's why it's 72 kilovolts. So yes, your answer choice is either this or this. So then let's think about the direction. So this is an electron. Okay, so we're gonna use our left hand. And I'm gonna figure out what the direction of the magnetic force is. So the magnetic force, because it's an electron, left hand, is V. V is your pointer finger, right? And V is pointing this way. And then B is the magnetic field. The magnetic field points into the page. So that's going to be like this. I know looking at the camera, it looks like it's coming out of the page. But, can you, yeah, I can't change the code right now, shush, but, yeah, just give me a second. Okay, so this is V, this is B going into the page. So that tells me the force, F, is going to be pointing down, okay? So B points down, magnetic force. Okay, so now I need the electric force to point up, all right? And the electric force is equal to QE, which, okay, so if F is equal to QE, and then Q is negative, okay, that means the force is going to be in the negative E direction, okay? But I need the negative E direction to point up, right? In order to cancel this out. So that tells me that the negative E direction would be the negative Y hat direction. Okay, I'll look at it. Shush, give me a second. There can't be 18 questions. There's only 12. This is the negative Y hat direction. And then negative Y should be negative J. Okay. So I think this should be the answer. Did they say this was the answer? Did they say it was C? Waiting for Oates to see. I'm pretty sure it's the last one. It looks like everything because everything's squished. Here, let me see. It doesn't look too squished for me. You just have to zoom out. You have to zoom out a little bit. But yeah, if these are all the same question, A6, B6, A6, B6, yeah, you can't do that. Okay. A6, B6. Jonathan, I'll let your first question go. I'm gonna have to remove your other ones. I agree, because otherwise it does get ridiculous. Don't spam the queue. Be nice. Was Destroyer different? Yeah. There you go. There you go, Shush. Does that help you out? I think that looks better, right? Yeah. Also, anyone submitting like international math Olympiad questions, these are gonna get skipped like right away. I'm just not gonna do them. Lovely now. What's up, Rex? You're correct. It's negative. Yeah, cool. Well, I mean, there's a couple things here. First of all, that it's negative J and not positive I. So I is in the X direction, which doesn't make any sense because the force due to my magnetic field is in the up-down direction, which is the Y direction, which is the same thing as the J direction. So even if I didn't know the plus or minus, the fact that the number matched up, the 73, and it matched up with J, automatically, this is it. If they wanted to be tricky, they should have also made this an answer choice. So, yeah. Does that make sense, Oates? The direction, does that make sense? Again, left hand for doing this. Yeah, good. Okay, cool. Awesome. Great. You're welcome.
I'm going to say that
Okay.
Math Olympiad question still in there.
What's up?
That Math Olympiad question still in there.
Oh, it's okay. I mean, if it gets picked, I'm just gonna skip it, but I'll at least put it in the Discord. Yeah. Though I appreciate you guys trolling me, but like I don't have time to do an international math Olympiad question. I'm not that smart.
Surprise, motherfucker.
Okay. Even the smart people for international math Olympiads, they take like 40 minutes for those questions. Okay, let's go see. Let's go see what the queue's at. Let's go choose a winner and see who we get.
Let's go gambling.
DM Screeder! It's okay, Tesco. You're at 23% chance now. So you're like 1 in 5. We like gambling. Okay, let me see what the question was. Sorry. What is the radius of the sphere? Ooh, I like this. This is a great question. Very cool. I like this one.
Let me be clear. If you are posting international Math Olympiad questions, stop being a bellend.
Oh no.
Don't be a bellend. Sensation will find you.
Or else, and I'll get my sock full of batteries.
My sock full of batteries?
That's what we used to use as kids. We used to start just
Beat
swing
each other with
socks
socks full
battery.
of batteries? Oh my god.
Around the legs, yeah, but you know,
Okay.
never go for the head.
What's going on in Ireland, by the way, right now? I have to go there for a wedding next month, but I see there's like some severe like civil unrest happening.
The Republic or Northern? They're two different
Something with
countries.
the IRA, dude. Apparently the IRA's
Again?
doing some shit, dude. Dude, go
I
check.
assume
IRA
they
beat up.
ran out of beer or potatoes.
I
One of
think
the
they,
two.
yeah, it's either beer or potatoes. No, I think they're running out of fuel because of
Guinness isn't beer.
our lovely president making the Strait of Hormuz closed, but
Guinness isn't beer.
Guinness is bread. I like Guinness. Guinness is fucking dope.
I mean, Guinness is not beer. It's is it a lager? No, it can't be.
It's a stout. It's a stout. It's a
I
stout.
don't know.
It's a stout,
I'm drinking
yeah.
moonshine.
Pretty sure it's a
so I
stout.
don't-
He's like, yeah, I'm from Tennessee.
Oh no.
I'm drinking moonshine. I got it from Cletus.
Cletus?
That's the best kind.
Yeah, dude.
I mean,
Cletus.
you
man.
ever had the home distilled shit? That it goes down smooth.
Oh my god.
I was on the beach one day. Dude was selling it out of a cooler. I was like,
Wow. That's.
I gotta
that's-
get some.
I gotta respect the hustle. Okay.
Just gotta be careful with them because you don't.
Yeah,
wanna
don't go blind.
get a patch. But
You gotta make sure it's
the problem
it's
is
not denatured.
No.
when you first distill it, there is like a layer. The first like 100 milliliters or so, depending on which like round you are in the distillation process, that is just methanol.
Yeah,
Which will, like,
that will make you blind.
Disqualified.
Don't do that. Don't do that. Don't do that.
so you
Oh,
gotta
no.
throw that out.
Yeah. All right.
If you throw
let's-
it out, you should be fine.
Yeah, as long as don't drink it. DMs. So if you want to find the radius of a sphere, the key thing to know is that the equation for a sphere is x minus h squared plus y minus k squared plus z minus, I don't know, l squared is equal to r. Is it r squared or r cubed? It's r cubed, no? Fuck. No, it's r squared. Yeah, I think it says.
It should be
The
R
sphere is
squared, yeah.
represented by 2 radii.
Sphere is represented by 1 radii, I think.
Yeah, it's
different angles.
one.
How is it?
Yeah, 1 radius, 2 angles.
1
Yeah.
radius and 2 angles. There you go. Perfect. Yeah.
Yeah, that's what I meant.
Yeah, you're good. So, DMs, what we're doing here is, so I rearranged the stuff with X to be in one place. And then I'm going to do completing the square to this to make it look like this. Akian says it's R cubed. Fascinating. But I feel like these are square distances, so this needs to also be a square distance. Right? Yeah, I think it's R squared.
3 radius, though. Radii.
No, these aren't 3 radii. All of these 3 things are going to add up to a single radii.
No. He said it's R cubed, so how can a sphere have 3 radii?
Yeah, well, yeah. It has
Well-
it has to do with units. It's not that
And-
there are 3 radii. It's like, is it the radii cubed? You know?
It should be R squared, because if you think about how you would figure out the total distance of that radius, you would take the square root, which lines up with our Pythagorean theorem in 3 dimensions.
Exactly. Yeah.
But it
yeah.
doesn't line up if you use R cubed.
Gotcha.
Domino's changed their app just for you, by the way.
What
It's
is
all
it gold? Is it gold now, dude?
looks
What's
like
going
it.
on in this? Here,
Oh
can
no,
I open?
I ordered it. And
Wait,
Is
I
it gold
don't.
now?
I don't want to put your address on there though. I'm not gonna put your address on the stream.
oh,
It has your address, dude.
Oh no.
indeed it does.
Yeah, it's all good. Okay, thank
But
you.
it's
Good.
gold.
But I appreciate that it's gold. All right, yeah. To do completing the square, you take whatever this number is, and then you divide it by 2, and then you square it, and that's 2 squared, and then you add and you subtract. So I fucked this up. This is 8 over 2, and then we're gonna square it, and so that's gonna be 4 squared, and then again I do plus 4 squared minus 4 squared, and then the same thing here. I'm just gonna skip the step. So that this is going to be 6 divided by 2 is 3. So I'm going to say plus 3 squared minus 3 squared. And then the beautiful thing about completing the square is that this whole thing here is, by definition, what's called a perfect square trinomial. So this can be converted into x, and whether this is plus or minus, and whatever this is squared. So this is x minus 2 squared. But then, key thing.
Oh no.
You got to remember that you still have the minus 2 squared here. And then here, so this would be y minus 4 squared, and then minus 4 squared. And then this one right here, that's going to be z minus 3. Dude, I love that your thing. Is that a PSA? And then it's minus 3 squared, and this is all equal to 7. So then here's the cool thing. Now you just gotta like evaluate what this is. So this is gonna be minus 4. This is gonna be minus 16. This is gonna be minus 9. All equals 7. And then we still have all the original stuff. Yup, there we go. So, last thing to do is move all of these things over. So, plus 4 plus 16 plus 9 is plus 29. And then that's going to get rid of all these. And so my final equation is x minus 2 squared plus y minus 4 squared plus z minus 3 squared. It's still r squared for a 40 sphere. For a 40 sphere? What? A 40 sphere, dude.
Yeah, it's always R squared. We used 240 sphere in thermodynamics.
That's pretty cool.
I just forget what we used it for.
Microstates or something. Okay, this is plus
Yeah,
36.
something like that.
And if this is supposed to be r squared, that means that r is equal to 6. So here's a cool thing. This is a sphere that is centered at, remember we said these were like this is the center of the circle. So you could say centered at 2, 4, 3, and it has a radius equal to 6. Nice. Good question, dude. Cool question,
This
Blue.
one cracks me up.
If you ever feel useless, remember that Scottish Gaelic Duolingo contains this phrase, I do not like whiskey. Yeah. What Scottish person doesn't like whiskey, dude? That's so wrong.
No one has ever said that in the history of mankind.
No, definitely not. No Scottish person has said that. I know plenty of people that don't like whiskey, but Scottish people, no.
No, they like it. They're just being paid by the government with propaganda.
Oh, it's like the people that say they live in Idaho.
Yeah,
It's a
exactly.
government conspiracy, dude.
Oh shit, not good.
Yeah, I've never met anyone from Idaho.
I've
No,
never-
actually,
yeah.
maybe I have.
I take that
Or
back.
might have been Iowa.
I've been to I actually have been to Idaho. I take that back, but now it's maybe Ohio. I don't think I've ever been to Ohio. Maybe that's the one that's not right.
Wait, what's
I
the
had a
joke?
friend
There's no
from one
people
of
in Idaho.
the
There's just potatoes.
states in the area, and it was so weird because it was like Idaho or Iowa or one of the like irrelevant states. You think it's just like potatoes and shit.
They
And
call
he's
it like
got
a
all these
flyover
crazy
state.
stories about like when
Sorry,
he was
Blood
with
Dragon,
the
this is on
Bloods and like dealing, and the DEA was investigating him and all this shit. And then it's like all in Idaho or some shit. And it was
Dude, I think
just
the head of the
like, of all
KKK is in Idaho.
states.
I think they have like their national headquarters are in Idaho.
I thought it was in like Mississippi.
No, I'm pretty sure it's look it up.
Tennessee.
Look it up. I think like the Grand Wizard whatever
Or maybe
dude is in
it
Idaho.
might be Arkansas.
It would be Arkansas, honestly. There's like nothing to do in Arkansas. Yeah.
I
Okay.
thought they were all dead by now. But
No, they're definitely not dead.
see,
All right,
what people
thanks
don't
for
remember about the US is there was an actual American Nazi party who were
Yeah.
active until at least 1980.
1980s? Really? It's a lot.
At least until 1980. I think it was actually past that.
Is that when what's that film came up? Dude, American History X. Such a good film.
One of that was 1999, wasn't it?
Yeah. Bite the curb. All right. Let me roll for a winner. See who we're gonna get.
I mean, I always
Who's
find it
gonna-
funny how people like piss and moan
Let's
about
go
stuff. It's like, oh, look how terrible the United States is. It's like, go look at a bit of recent history, eh?
No.
There was an actual Nazi party, people wearing the actual brown uniforms and everything. So don't fucking sit there and tell me
Dude.
how bad things are now.
Why would you wear the uniform of the losing team, dude? Kind of dumb.
Good question. Yeah, because they all moved to the US. Operation Paperclip.
Yeah. Yeah. Well,
An actual thing that not
we
a conspiracy
yeah.
theory.
Oh, I know. Yeah. No, we took all the German scientists because they were smart. Werner von Braun, dude. He basically created the NASA program to what it is.
Yep.
Nice. Good job, Pineapple. Okay. You will be marked for form, neatness, and presentation of the solution. Is this fucking Comic Sans, dude?
Irony.
That's propaganda if I've ever seen it.
Yeah,
Form,
what?
neatness, and presentation of the
Yeah, dude, what
solution.
is this, dude? Form, neatness, and presentation? What are these words, dude? Okay. Decimal answers are acceptable, blah, 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 blah. Please use online technology such as Desmos to verify your answers. Do not use it to produce the answers. This is the curve. Okay, cool. All right. This is actually a cool one. All right, y is equal to 5x over x squared plus 1. First thing I always like to figure out is what are the vertical asymptotes? Vertical asymptotes are when you can divide by 0. It is impossible to divide by 0 here because there is no way for x squared to become -1. Unless it was imaginary, but we're not dealing with it. Yeah, I know. You wanted to say it. I know. Okay, so there are none. Don't worry. You don't have to say like real or something. Horizontal asymptotes. Very cool. You can do this with the limit definition, or we can take the shortcut where we're just going to look at what the highest power on the top is. Highest power on the top is x to the 1. The highest power on the bottom is x to the 2. If the top is smaller than the bottom, this means the horizontal asymptote is y equals 0. We could also show that with the limit, but I'm just going to take shortcuts for now. Intercepts. Okay, those are good to know. So x-intercept, or actually let's do y-intercept is the easiest. Y-intercept is when x just equals 0. I always like to think it's the opposite, right? Y-intercept is when x equals 0. X-intercept is when y equals 0. When x equals 0, I just get 0 over 1. So that's just still 0. Cool. And then I'm pretty sure the x-intercept is also just going to be equal to 0. Because then what you do is you set y equal to 0. And the only way for this to be 0 is for the top to be 0. So cool. The x-intercept and the y-intercept are the same thing. They're at 0, 0. Possible critical numbers. Ooh. All right. Critical numbers, we got to go take some derivatives. So let's go figure out what y prime is. So this is I'm going to do the quotient rule. I know some people want to do the chain rule product rule. I'm going to do the quotient. So derivative of the top, which is 5, times the bottom, squared plus 1, minus derivative of the bottom, which is 2x, times the top, and then all over the bottom squared. And then what we're looking for a critical point is when this is equal to 0 or this divides by 0. Now, it can't divide by 0.
Oh, no.
Because there's, again, no way for x squared plus 1 to become 0. So we just need to figure out where the top is equal to 0. So the top is 5x squared plus 5 minus 10x squared. We're going to set that equal to 0. So that's negative 5x squared is equal to negative 5. Divide negative 5. X squared is equal to 1. So x equals plus or minus 1 are critical points. Cool. Dope. Create the chart. Okay, so then they want this. I think they want like x value. Yeah. I don't know what the chart is, but I think this is kind of how we do it. I think we say x, f prime of x. I could even do f double prime of x. I'm not going to. Or sorry, no, I need f of x, and f prime of x. 0 is also solution. Not as a critical point, no. Because this would be 5 equals 0. Yeah. Okay. So here, you have a critical point at -1. You have another one at 1. So then let's test some points in between. Well, I know at 0, the function's equal to 0. And also, what would the value of the derivative be? The derivative would be negative 5x squared plus 5 over x squared plus 1 squared. You only really care whether the derivative is positive or negative. So if x is equal to 0, cool, this is positive. Here, it's 0. What's the function at -1? Well, that's over here. That would be negative 5 over 2. So I'd say like negative 5 halves. And then if it was positive 1, it would be positive 5 halves. Okay, perfect. Okay, so derivative is positive here. Derivative is negative here. We should check another point. Let's check out at -2, and let's check out at positive 2. At -2, this becomes -2 squared is 4. 4 times -5 is -20. So this is going to be negative. And then at positive 2, same shit. It's also going to be negative. And I don't really care what the function is here. I'm not going to do it. All right, cool. Because now if you want to draw it, this is great. No vertical asymptotes. We don't need them. We can draw a horizontal asymptote. And we can start putting in some points. So I know 0, 0 is a point. I also know 1, 5 halves is a point. And I also know -1, -5 halves is a point. And then this already kind of like helps you just do this. Because you know it has to approach the horizontal asymptote. But then this makes sense, right? If something's going from down to flat to up, this is a minimum. And if it's going from up to flat to down, this is a max. And that's what we see. This is a max. This is a min. This is all the intercepts. And so I guess if they want you to graph them, it's like this. And there you go. That's a speed run, but we did it. What's up, Pineapple? Oh, nice. You got into college. Fuck yeah, dude.
That's dope.
Can I share this on the stream? Oh, sweet. Okay. No, I love this stuff. You guys are getting like college letters and stuff. Yeah, congrats, dude. Dear Pineapple, you have gotten into Toronto Metropolitan University. Nice for engineering. Dope. And you're gonna be doing mechatronics. Wow, congrats, dude. Proud of you, man, dude. It's hard to get into college, let alone get into college with an engineering major. We had another student who got into Waterloo, I think, for what was it? I think he was also like
I think it was mechanical.
I think he was mechanical engineering. What's the difference between mechatronics and mechanical?
It's mechatronics is like a mix of electrical and some mechanical.
Oh, so it's mechanical electronics.
And a little bit of like a little bit of comp sci stuff. So it's like everything to basically build like a robot or design.
Oh, very cool. Dude, that
and
sounds
then
dope.
mechanical is about 95% whining and bitching about what you're doing, and then about 5% doing it.
Actually doing something productive.
Yeah.
Yeah, I feel that. Nice. Well, that's gonna be super fun. Waterloo's like I know Waterloo's a very difficult college to get into. But also, yeah, the Waterloo effect. Sometimes you don't want that.
Surprise, motherfucker.
And I always say you want to go to a college, not necessarily because of the name or like whether it's hard or whether it's easy, but what the opportunities are for you to do things. So I know some people that will like sacrifice their major to get into a good college, but then they're doing like some major they don't even want to do. So there's like tricks of if you're smart and you want to go to, I don't know, let's say like UCLA, you would apply under psychology or something that's like easy for you to get in, but then it's kind of a bitch for you to like actually go and do engineering. That's worse than going to, let's say, Cal State Pomona or something, where like they would let you straight in with engineering. It's better to go to somewhere where there are opportunities. The name and whatever I think is mattering less and less. It's just about what can you do. What's a better university, UCLA or UCI? It depends what you want to do. I think technically UCLA is ranked higher, and I teach at UCLA, so I'm kind of biased.
Oh, no.
But if you live in Irvine and the commute makes more sense, and maybe UCI has a better, I don't know, maybe they have a better computer science program than UCLA, then go to UCI. Oh, yeah, co-op for Google and Apple. Yeah, I'll agree that the name can matter there if you're trying to get internships. The chance is higher. What makes the chance the highest is what you do in college. So I went to University of Texas. It's an okay school. It's not like an MIT or whatever or Harvard. But I got into UCLA for grad school because at UT, I had opportunities to do like actual research, and I had a lot of really good connections with my professors, and they wrote really great letters. And I don't know if I necessarily would have had that, let's say, had I gone to Yale or had I gone to Harvard. I would have probably been drowning in like competition and, not able to have the same set of opportunities. So it's about what you do. So even my advisor at UCLA, he went to UNC, I think, or North Carolina State. I don't know. Went to some kind of like whatever college in North Carolina, and then ended up going to Princeton for grad school. And now he's like the director of Oak Ridge National Labs. So where you go to undergrad does not really matter so much. It's what you do there. So go somewhere where you can do the most shit that will then get recognized for you applying to jobs or to grad school or whatever. Yeah. Anyways. And rent. I don't know about University College London. I've never been to UCL.
It's like nobody here calls it UCL.
What do you guys call it?
Not unless that's changed in the past 10 years. Obviously, University College London. I mean,
okay. If
you get in there, you don't ever want to make the contraction. You want to say very loudly and very proudly, I'm going to University College London.
Taco Cat, I forgot to ask. What were you going to ask Taco? How was Japan and what did you get to do there? Oh, yeah, Japan was dope. I'll make a post. I'll make a little recap picture showing you guys everything. But yeah, Japan was awesome. Definitely recommend people go. All right, let's choose a winner. I want to make sure we got time for everyone. A lot of questions today.
Let's go gambling!
Oh, no, let me give you a point, Blue. Sorry, my bad. I love my dog. You won with a 6% chance. Wow. And then this was to Lucky Cat. Okay, let's see what we got. What do you got for me? Was it a solo trip? No, I went with like 3 other friends. Solo trips are great. I have done a lot of solo trips in my life, and yeah, not having the safeguard of I can just talk to my friends is great because it forces you to go make friends with other people. Go do it.
Or you sit alone for a week in a hotel in a different state.
Oh no.
No, dude, your body will naturally go find friends, dude. Does the Let's Go Gambling violate the non-profit morality regulations?
Oh, dang it.
I don't know. Sue me. I mean, yeah. I mean, technically, there is gambling because you're gambling with your time, but it's your time so we can help you. So there's no monetary gambling happening. It's just probability. Which is what this question is. Let f of z and g of z be probability generating functions. Let h of z be a summation of the two, where p plus q is equal to 1. I like that because I need the total probability to add up to 1. This is called a mixture of f and g, and it corresponds to flipping a coin and choosing a probability distribution f or g depending on whether the coin comes heads or tails. Find the mean and the variance of h in terms of p and q, and the mean and the variance in terms of f and g. Oh, wow. Fuck. The mean... Okay. The mean and variance of h in terms of p and the mean and variance in terms of f and g? I mean, the mean is just going to be p times f plus q times g. Right? And then the variances will sum. Right? Because these are probabilities, yeah? Yeah, so kind of... So, yeah, I'm curious. Like, the mean of h... Oh, I see. And find the mean and variance of h in terms of... And then it's p, q, and the mean... Okay, got it. I know what's going on here. Okay, so the mean of h is going to equal to... And then here, we're going to represent mean as like a bar. So I'm going to say the mean of f is equal to f bar. And then let's say the variance of f is equal to like, I think we say delta squared f. Is that what we say? Yeah. Is this kind of how we would write it? I'm going to call this like variance. Because variance is standard deviation squared. What is even what even is a probability generating function? I think it's just it's a function that just develops like a distribution or something. What the heck is a power series whose coefficients are the probabilities of each natural? Yeah. Yeah. Okay. So the mean of h is this like the expectation value of h? So we're here. Let's call this h bar. That's going to be the probability p of f happening. So it's p times f bar plus q times g bar. Okay. Yeah, it's a power series. Okay. And then if we, yeah, because you have a bunch of different probabilities and outcomes. If we want the variance of h, the variances, do the variances add, Jeff? They do some. Okay. So this is going to be the variance of pf plus the variance of qg. And then what Jeff said, yeah, the rule for this, when you do the variance of something multiplied by something, you square that multiple. So this is going to be p squared, variance squared of f, or variance of f, sorry, plus q squared, variance of q. Why do people ask me questions when ChatGPT exists? I mean, human interaction is still a valid thing. Also, sometimes chat just doesn't put it in a way that makes sense, and so it's cool to see what another human thinks about it. Sorry, did I put the wrong thing? Did I say F and G? Wait, what? Do you mean G instead of Q? Oh, sorry, yeah, sorry, I wrote this wrong. Sorry, my bad. I don't know why I wrote 2 Qs. Thank you. There we go. That's what I meant to say. Also, I mean, it's just fun to ask questions. Even if the answer is known, there is, you know, this is always my parallel with the gym. We have things like forklifts, right? Forklifts exist. So what's the point of lifting weights when I could always just get a forklift to lift it? And then the reason is because you don't build any muscle just using the forklift. So if you're just always using ChatGPT to get the answer to things, but not actually taking the time to like understand it, understand the steps, then you're not building any like mental muscle. You're just, I don't know, you're just watching AI just like jerk itself off or something. I don't know.
Oh no.
It's like, great. AI is smart. But if you want to get smart, you need to do the things. And sometimes asking a human to do it and watching a human go through that process, that builds, you know, brain power and stuff. Yeah, chat can explain it step by step for sure. But I mean, are you actually learning? No, and I agree. Like, if you are actually using ChatGPT and you're using it to learn, then sure, great. You don't need me at all. No, there's no need for me, dude. Like, replace me, dude.
Oh
If that was the case, dude, I'd happily quit, because then there would be no need for me to help people, because everyone else would just help themselves. The truth of the matter is, as humans, we're lazy.
no. Oh no.
And sometimes you need a format like this to coax that learning process out of people. What's up, Zach? Sorry, what?
I'm sorry, I have to stand against you on that one. It's not necessarily laziness. Some people just need provocation.
Sure.
Surprise, motherfucker.
But it's not necessarily a function of choice. There's plenty of things I can't do unless somebody provokes me to do it.
Yeah. Your provocation.
I don't know. When did you have a shave today? And I'll say no, and they'll say go get a shave.
Yeah.
If nobody told me to do that, I wouldn't do it.
I agree. If I don't have to go out and like see girls or like other people, I just won't shave. I'll just be like, whatever, you know. I'm happy with myself right now. But if there's a reason for me to go out and like look better, then yeah, I'll go do it. So it's like I don't think like girls put on makeup at home with no one watching.
Oh no.
It's like, what's the point?
Maybe it's a poor example. I don't know.
Yeah. If you were offered a position as a professor at Cambridge, would you move to the UK? Probably not. I don't know.
No,
I like the UK.
don't.
I'm a British citizen. I do have a passport, and my mother was born in Cambridge. So, and I am going to go to Cambridge actually at the end of May. I will be in Cambridge, but I would not live there. There's nowhere to surf, and the weather is really wet, and it's, I don't know, depressing and all sorts of things. I am a British citizen technically. I'm a U.S. citizen first. I have dual citizenship. But yes, nice, good question. I love my dog. What up, Zach? Good to see you, dude. Welcome. Zach, do you have a platform for me to like check out? Remember, Thursday's the deadline. You gotta give me the MC console for me to test out for the game on tonight. You will. Okay. I guess we'll meet Saturday then, maybe to go through it. There are 5 hours left. There are. Yeah. All right. Let's see. Let's go spin another winner. See what we got. Whose question's gonna be?
Let's go gambling.
Yeah. Also, Pineapple. If there's a way for you to get out of chem with like AP credit or something, that's really great. That's what I did in college. Good job, Gladiator. Testicle, dude. You have to be next, dude. You're the top vote now. What do you do for a living? I do a lot of things. I just filed my taxes today, actually.
Yeah.
This is the first year in probably a decade that I'm getting money back. I've always had to pay like a ridiculous amount in taxes because a lot of my money is in what's called like the gig economy, like 1099 stuff. But I only recently started getting W-2s, and they like take your money out ahead of time. So I'm finally getting money back from the government now with taxes. Yeah. But yeah, I do this. I teach at UCLA from quarter to quarter. I'm going to teach next summer or this summer. And then I work at a couple startups. And then I tutor as well. I don't really tutor as much anymore. But And do it right, not my way. Okay, here we go. Find the slope of the line tangent to the curve. Okay, so the slope is going to be the derivative. I am going to do it my way. I'm sorry, dude. It says don't do that.
Ooh, wow. Chris Brown, dancer extraordinaire. Wow. Whoa.
Okay, I am going to implicitly derive this. Yeah. So implicit differentiation.
No.
No.
I don't
No.
want to. I'm scared.
Dude, I think it's actually kind of necessary here. Well, I guess we don't have mixed things. It's a legit way. You guys don't get mad at me. Okay, whatever.
Implicit differentiation is legit. Dividing by dt, it's not.
Okay.
Surprise, motherfucker.
Can we abolish negatives? I keep forgetting them or adding them for no reason. Oh no, dude.
Oh no.
I'm sorry. Yeah, we do need negatives. Okay. Okay, so I'm going to treat everything as a derivative, and whenever I do the derivative, I'm going to either write dy or dx. Derivative of x is just 1, and I'm going to write dx after it, because I took a derivative with respect to x. This is a product rule, so I have to do the derivative of the first thing. Derivative of y is 1 times the second, ln of y, and then I got to slap a dy on that, because I took the derivative with respect to y. And then it's plus the derivative of the second thing, but watch out. There was a minus out front, so it's plus minus, so it's minus the derivative of ln of y, which derivative of ln is just 1 over y, and again, then times y. Dividing by dt is allowed except if you're a formalist. Yeah, yeah, I don't know. All right, derivative square root of 3 is 0. That's a constant. We don't care about that. Derivative of pi over 3 is a 0. Great. And then plus tangent of x. Derivative of tangent is secant squared. So I'm going to say secant squared of x, and then that's dx. All right. Next thing to do is put all the dx stuff on one side, put all the dy stuff on another. I'm going to move these things over. I'm going to move this thing over here. So I'm going to say like 1 dx minus secant squared dx is equal to ln of y dy plus y over y is just 1, plus, so just plus 1 dy. And now I'm going to group. So this is going to be 1 minus secant squared dx is equal to 1 plus the ln of y dy. This is a trig identity. 1 minus is this a trig identity? Isn't it 1 plus tangent squared equals secant squared? So I think 1 minus secant squared is the same thing as negative tangent squared. So I think this is negative tangent squared. And sorry, this was of x. I forgot to put the x. Dx is equal to 1 plus ln of y. Secant squared is unforgivable. And then we divide this, So I get negative tangent squared of x over 1 plus ln of y is equal to dy over dx. And this is the slope of the tangent line. What are my thoughts on Chem E? Chem E is a great degree. Yep. Especially if you live in Texas. Go get a nice petroleum job. X equals pi over 3. Y is equal to 1. Let's see what we get. So if we plug that in, ln of 1 is 0. So that's just going to be over 1 plus 0. And then tangent of pi over 3. Interesting. So let me remember. If I draw my triangle, pi over 3 is 60 degrees. If I could draw 60 degrees today, be nice. There you go. All right, so 60 degrees. This is square root of 3 over 2. This is 1/2. So the tangent is the opposite over the adjacent. So that's equal to the square root of 3. So tangent of pi over 3 is equal to square root of 3. And then we're squaring it, making it negative. So that's going to be negative 3 over 1. Very nice. So dy dx. Uh-oh, Jeff.
Surprise, motherfucker.
Did you lose some more years off your life? Dy dx equal to negative 3. Beautiful. Cool. Great question, Gladiator. It was a fun one. Nice, Gladiator. Hope that made sense to you. Did you get this from the textbook that we sent you? AFG sent it to me, actually. If anyone needs, like, I don't know, like, I know some of the students in my Discord are complaining that their school's absolute shit.
Oh no.
Like, they're not learning anything and stuff. And I say to you, you know, don't let that hamper your future. You can always try to self-teach yourself. Again, this is probably the motivation provocation thing. But I have some really good textbooks that you can kind of self-learn from if you're not feeling educated by the class you're in. This was in the 50 challenging questions? Cool. Oh, nice. Oh, you found online. Dope. Oh, so I guess they found a PDF breasticles of that book you had. 50 challenging
so
girls?
Yeah, I thought that one looked familiar.
Nice. Gladiator, send me that PDF. Can you DM it to me if you got it? I'm just curious. I want to see it.
Yeah, there it is. That's good.
Cool. What's up, Sensation? What were you going to say?
Yeah,
When a student comes to you and says, "My school is shit,"
Yes.
and then they're posting questions from their school, say no. But what do you not know? Because I guarantee you, if their school is as shit as they say it is, then they won't know things at a lower level than what they're posting. And it's more important to have a firm foundation to stand on
100%.
than
I agree.
simply do whatever the school throws at you.
I agree that foundation is very important. I do. Yeah.
Because you won't understand the answer to the question.
Yeah.
You'll just have the answers being given to you by you.
You're just a
defeat the
calculator
point.
at that point. Yeah. Wow, lots of questions in the queue today. All right, let's go choose another winner.
Or if that's too subtle for you, stop being taggy bastards. Right?
Unlucky cat.
Oh no.
I'm starting to realize I might have to change the, what is it, the, because poor testicle has been like just chilling here waiting. But there keep being more entries coming in, and it is diluting the percentage. Interesting. This is unfair. I agree it might be. So I'm trying to think how I would fix that. Shush. I think what I need to do is put an exponential gain on votes based on the amount of time you've spent. I think amount of time spent shouldn't be linear. Yeah. No, I appreciate. This is what we call like stress testing an algorithm, because I don't know, we've never had so many people submit questions. So I'm gonna add that to my list. I'm gonna say have votes gain exponentially with time, because I agree, if you wait a while, you should like have a better chance. It shouldn't be linear. And then also I'm gonna put a more timeout on IP address, which I don't think is an issue. Shush, because I'm looking at the questions that are getting submitted, and it's pretty spread out. 1 minute ago, 4 minutes ago, 7 minutes ago, 22 minutes ago. It's not like someone's doing it every 30 seconds. So I think the timeout is fine. I think it's just the amount of time you spend should be not linear. Yeah, this is not Pineapple's question. Yeah, okay. Let b naught be 0, and for n equals greater than z equal. Oh, okay, so this is recursion. Okay, so the next term is equal to 2 times the previous term squared plus the previous term plus 1. For each k greater than 1, show that b. Oh man, what's going on here? Is this an exponent here? Sorry. B to the 2 to the k plus 1 minus 2b to the k is divisible by I don't know if I can do this.
Oh,
Too many things going on. By 2 to the 2k plus 2, but not by 2 to the 2k plus 3. Fuck. Okay. All right. Let me. So we have like superscripts and subscripts. Shush, skip. I will give at least 10 minutes to trying this. Yeah, I will give a legitimate attempt, and then yeah, I will pass if I can't do it. It's okay. All right, so the n plus 1 term is equal to 2 b to the n squared plus b to the n plus 1. So I want to know. Let me try to define what's the to the 2k term. You can find a closed form if you know the sum formulas for squares and sequences of integers, which you can find. The sum form for squares and sequences of integers. What would that be, Jeff? Sorry. Yeah. Okay, so b to the 2 to the k plus 1 would be... Oh, man. I'm trying to, like, relate this to this. Oh, like 1 squared plus 2 squared plus 3 squared plus n squared, yeah. Okay. It's just, I got 2 variables I gotta deal with now. Fuck. Alright. Let me consider k equals 1. Let me just do it. So that would be b to the b4, right? Because that's 2 to the k plus 1 would be 2 to the 1 plus 1, so that's 2 to the second. And then minus 2b to the 2b to the 2. And then we're saying this is divisible. This is the most difficult question on the Putnam competition, the hardest exam in the world. Okay, well then I'll probably pass on it. Divisible by... It's fun to look at it at least, though. Okay. So this would be 2 to the 4, but not by 2 to the 5. And then what would B4 be? So B4 would be... Oh, man, I'd have to do this, I'd have to do this a bunch of times. I'd have to do this 3 times. And B0 is 0. Okay, so, like... Oh, shit, it's A6. You ain't getting the answer. Okay, let's go look at what this is. Yeah. All right, yeah. If this is something ridiculous, I am not going to attempt it. Just to be fair to everyone else.
Yeah, I think that was Putnam.
I don't see it in Putnam, though. No?
I could be wrong. I feel like I've seen a similar, like A6, B6 type of notation.
Oh, okay. Let me see. Like Putnam.
But I don't.
Math question.
Yeah, I could be wrong. I don't really try to solve those.
Okay, Putnam can't even do A6, B6 Putnam. Do they? I don't see any formatting here on the A6. Oh, here we go. Yeah, they do call it like A1, A2, A3. Uh-huh. Okay. Yeah. You know, it didn't look that bad at first, but then I just see the level of recursion you got to do is really intense. Because it's like series of series type stuff. A6 problems are usually evil difficulty. Okay, thank you, Zach.
Oh, no.
Okay, well then, you know, I appreciate the math warrior in this. I will send this at ChatGPT. Let's send it at the highest version. Let's see if it can do it. And then while we do other questions, I'll take a look. So let's put it on extended thinking, and let's just tell it to solve this. I just want to see if it can, because this is on the latest ChatGPT. We could do like deep research if we want to. It'll get there because there's published solutions. Okay, here, let's just have it go. I'm gonna just have it go. But anyways, okay, cool. Thank you for the question, Unlucky Cat. Yeah, I generally have just like for rules, I have a ban on JEE questions or anything else that's like an insane math competition question. I get that it's funny to watch like, ooh, can he do it?
Oh, no.
And I appreciate seeing them, but yeah, I will very quickly admit like what my capabilities are, and it's not that. All right, so that being said, let's go see something else. Maybe it'll be you today.
Let's go gambling!
Hey, Gold, you want to solve an integral? It's gonna be a nightmare. Rumble, okay. Let's see, did Rumble also? Oh, okay, this is cool. This is not bad. I can do this real quick. Okay. Show that the equation, 2x sine of x is equal to 1 has 4 roots between negative pi and pi. Roots? What do you mean roots? You mean like, oh, things where like it equals this? This is unfair. I'm sorry, Shush. I can't change it. I can change it after this. I can't change the code like during the stream. It's a journey to get there. Solutions, I think they mean. Yeah, okay, cool. Between pi and pi. Do you think I do a series expansion for this? Because that's telling me x sine of x is equal to 3/2, right? Probably. Oh, I see. Probably intermediate value theorem. Yeah, x sine of x minus 3/2 is equal to 0. I know you have Shush. I'm sorry. It's how the cookie crumbles, dude. Are you hitting upvote every 3 minutes? If you keep doing that, it'll get you. Okay, so I just need to find places where it crosses. Because this derivative, maybe if I found critical points, would that help? Because those would be turning points, right?
I think you could just figure out the zeros of sine of x from negative pi to pi.
But then that doesn't help me here. Because I need it to be this minus 3/2 is equal to 0. These have to multiply to 3/2.
Yeah, but either your x is going to be 0 and x is only 0 at 0, or your sine is going to be 0. Since we're only worried about the roots.
You also have finite bounds. Okay. I feel like I want to do a derivative. I feel like if I have turning points, this will help me out. Not quite. Tit boy? Who's tit boy?
Oh shit, not good.
What's tit boy? Oh, tit boy's breasticles.
Oh no.
Who's tit boy? Yes, I agree, Jeff. I agree with what Jeff is saying. Let me figure out what y prime would be. So derivative of the first is just 1. So I would say like sine x plus the derivative of the second, which is going to be x cosine of x. And I want to figure out when this is equal to 0, right? So that's sine of x over cosine of x is equal to negative x. So when is tangent of x equal to negative x? Man, this is weird too. Man, is this one of these wolves and sheep's clothing question again?
Oh no.
That's kind of what it's seeming like.
Right? Yeah, I'm just dealing with like 2 trig functions. When is tangent of x equal to x? Oh, man. The issue is that tangent can go from negative infinity to infinity. Oh, wait, but x is bounded by 0 to pi, from negative pi to pi. Okay. Yeah, let's do that. Okay. Got you. Okay. Use the Newton-Raphson method. Oh, I don't know what that one is. Let's check the bound. Let's check the endpoints. Let's check endpoints. Okay. So, let's say this is equal to y, because essentially what I'm doing is I'm solving for the roots of this. So at negative pi, sine of negative pi is 0. So so you have negative pi. All right, let me say x, y, and then y prime. Okay, so at negative pi, I have negative 3/2, and then for the derivative at negative pi, that's gonna be equal to pi, right? Because cosine of negative pi is equal to -1, but then -1 times negative pi is gonna be +1. All right, let's check at pi. The value for y will also be negative 3/2. Right? And then the derivative will end up being negative pi. Okay. And then this is also kind of whatever. Okay. So on my graph of things, right, if this is negative pi and then this is pi, y is always equal to negative 3/2. And in this case, it's pointing up. And in this case, it's pointing down, right? So I know for sure there has to be at least one turning point, so there has to be at least 2 roots. Assuming this is, yeah, and this is continuous, right? There's nothing wrong with this. Okay. So I've proven there are 2 roots, at least. No? What do you mean no? Jeff. It's possible. Okay, you're right. I just need to show one place where it's positive. So maybe let's come up with one of those. I think I could do that at, oh man. X equals 0. Yeah, but then that gets me negative 3/2 again.
Huh?
Which I don't really want, right? Yeah, 0 doesn't really help me. 0 is also negative 3/2. And then what would the derivative be there? The derivative would be 0. Oh, very cool though. Wait. This is flat though. Yeah. Yeah, and then let's check negative pi over 2. This is, we're basically just graphing it. I want to know if there was like an algebraic way to do this. Okay, but negative pi over 2, sine becomes 1. And then I have negative pi over 2 times 1 minus this. So this is like very negative, right? Oh wait, no, sorry. Sine of negative pi over 2 is negative 1. Negative 1. So this is pi over 2 minus 3 pi over 2. So that's going to be positive. Okay, so it is here. And then I think at pi over 2, same, wait, pi over 2, sine of pi over 2 is 1. Okay, so then I get 1 times pi over 2. Pi over 2 is also positive. Oh, good. Okay, so there we go. All right. So then, yes, if it goes from here to here, then it must cross there, and then it must cross here, and it must cross here, and then it must cross there. This shows at least 4. Yeah, to show that they're exactly 4, I'm not so sure. I think I have to show that it's strictly increasing from here to here, and that it's strictly decreasing from here to here, right? So, y prime. So maybe I need to do y double prime, because that's when the first derivative changes, right? That would be an inflection point. I mean, otherwise I have to show that sine of x plus x cosine of x is always positive, which I think is hard to do. From negative pi to that. So I think I need y double prime. That's cosine of x. Yeah, exactly. Yeah, that's what we're gonna do. So so that's cosine of x. And then this is, okay, so plus cosine of x. And then plus, so minus x sine of x. And so that's 2 cosine of x minus x sine x. And so I'm assuming it does like this. Okay, so between negative pi and negative pi over 2, let's just check. So at negative pi, this would be negative 2. And then that would be plus... No, sorry. That would be 0. Sorry, no, okay. Y double prime of negative pi. This is negative 1. So it's -2, and then this is 0. Okay, so that's negative. And then y double prime of -pi/2. This goes away. And then that would be negative. And that would still be negative. So it's still negative. I don't know. Does that show it changed? I feel like maybe that shows that because the concavity was always the same. That, like, yeah. Okay. I'm just in the interest of time. I'm gonna be like, cool, we showed 4. If someone else wants to help me out showing that there's no more than 4, all up for it, but cool. Otherwise, yeah, this is fun. It's fun little exercise and trying to do things. Rumble. Cool question, Rumble. It's like mostly there. I need to think more about the derivatives and the second derivatives. And like, I need like MBT, IBT stuff. Is it a competition question? I don't know. People do seem to be submitting competition questions today. Okay. All right. Let's choose another winner.
Let's go gambling!
I'm Batman.
Jonathan. It's getting closer. Testicles, dude. I might just skip this. I'm gonna skip this right away.
Oh, dang
Yeah. No Putnam questions. Sorry. We're gonna spin again.
Just throw yourself out a window.
Go gambling!
Whack. Fucking asking stupid questions like that. Here's a new word for you. Defenestrate.
Defenestrate.
That's to throw someone out of a window. I remember learning that in Latin. That's probably the only thing I actually remember.
All right, this is
Latin.
actually doable. This is doable, I think. I'll do
No,
one
I
of these.
remember orta means guard.
Defenestrate isn't a Latin word though.
Yeah, I just my Latin teacher just like brought it up one day. He was an interesting dude. He would just kind of talk about random shit like that. He taught Latin at a high school, but he had a whole ass computer science degree. He was just like, yeah, I'm the only one who knows
They'll
how
get
to
bored.
teach Latin.
What a useless language.
Not good.
All right.
There's AP Latin too.
How do we do this? Oh, I think I know how this is, right? So if I want to do the partial derivatives of the following. Sorry, is this like df dx is equal to something, and then I also need df dy? Because there's 2 variables. Who knows partial stuff?
I know partial derivatives. Just it's kind of. I feel like they're missing some information in there.
I remember it's like if it's like df d whatever, it's like blah blah blah. It's like df dx plus df dy, and then like plus df dz, right?
Multiplied by dt, but that's your total derivative.
Yeah, and then we have to like. I remember we have to go down like a nested loop of this, right? Because then f is equal to g of x, k of y. Oh man. Okay, I think they want 2 things. I think they want df dx, okay, which is gonna be df. Oh man. Is it df dg ky plus dk? No, it's this is Putnam A4. Wait, is this Putnam A4? This doesn't look like a Putnam question. It says 2-28. Shush. Sorry. You have to like build like families, right? Okay, so it's like f is a function of x and y. But f is a function of g K and H, and then H is a function of Y. K is a function of Y. G is a function of X. I remember it's stuff like this. And then you have to like go all the way down. And it's something like df dx is equal to like df dg dg dx, right? Plus df dk? Yeah, plus df dk dk dx plus df dh dh dx. Yeah, that's how you do this. But then k is only a function of y and h is only a function of y, so don't these go away? So you're just left with this. Oh man, you guys bring in the hurt today, dude. What the fuck? Yeah, shush. Yeah, we changed it so you... Well, people were, like, seriously gaming the voting system. Oh, wait, no. I need to, like, just... Sorry, tell it what I actually need to do. Sorry, yeah, you can stop on this one. Oh, here's the... Okay, yeah. Oh, it did find the partial derivatives. That's cool. I didn't even give it the description. It just found them. It just knew I needed to do it. That's too funny. Okay. Okay. U is equal to gx ky. V is equal to gx plus hy. So it's f of u of u and v. So df dx is df du ux, and then plus df dv dv dx. Okay. Okay. And then you substitute them in and you get this. Okay. All right. In the interest of time, just because I'm running out of time here, I'm just gonna at least post this. It's something about like, yeah, you build like a tree and then you go down, but I don't have time for it. Okay, cool.
That's dope.
All right, let's see. Goodwill. Okay. All right, let's see what's next.
Let's go gambling.
Oh. Wow. Shush, it's your turn, dude. Are you ready, Shush? Are you ready, dude? You dropped me like a whole fucking lab report, though, dude. This is too funny. Can you solve JEE Advanced? No.
Oh no.
Nope. Not doing JEE. Say it again, you're gonna get muted. Don't say it.
One day, just for shits and giggles, I'm gonna submit the Riemann Zeta hypothesis.
People try to do that. Dude, every month someone tries to get me to solve the Riemann Zeta hypothesis. Okay. There we go. A 230 volt, 1 kilowatt heating element. Great. The length of the wire is a spiral groove. You're doing JE on Wednesdays? Are you, Penn? Bless you.
Oh no.
Bless you. Thank you again for this, for the 27 months. Wow, dude. Thank you, Penn. Shout out to Penn. Penn's great. Okay. There's a lot of stuff going on here. The student wishes to find out which reel holds the same wire as that was wound on the heating element. The book of data gives the following information. This is gauge, I guess. Diameter cross section. Show that the resistance of the nichrome wire wound on the ceramic cylinder is resistivity of nichrome and operating temperature. Oh, okay, is this? I have a PhD, Narendra. I have to leave to pick up David. Okay, nice.
Oh, yeah.
Good luck at the airport. Sorry, what's going on here? Okay, 18 centimeters. The diameter is that, and the distance between the centers of the adjacent turns is 1.5. Okay. So, let's figure out how many turns there are. So, number of turns is equal to 18 centimeters divided by 1.5 millimeters. So what's that? So 0.18 divided by 1.5 e to the minus 3. So it's 120, okay. 120 turns. And then we know the diameter is 1.4. So R is equal to... Oh, okay. So that's the number of turns. And then each turn has a circumference. Right, so here's a turn. But then this is going to be 0.7 centimeters. So circumference of one turn is equal to 0.14, sorry. Times pi. Great. So if I do this times this, I'm going to get the total length of wire, I think, that's being used. Yeah. So total. Length of wire.
Did you answer that question?
Which one?
He wants to know if you got a bachelor in sciences.
Yeah, I have a PhD, dog. I did tell him. I think I told him. It's okay. I don't know. Even a PhD, dude, like, we have multiple math PhDs even in the stream right now, and they won't do JEE questions. We agree they're just mean.
It's not that. It's just like, open thine fucking eyes and pay attention.
Yeah. Or they could click the bio page. I don't know.
Yeah, that's what I'm saying. It's like, look.
Look, dog.
If you don't even have basic perceptual ability, you're fucked forever.
Surprise, motherfucker.
Yeah, I love a real sensation. I've missed you, sensation, dude. Just keeping it real. Just be like, nope, you're just a fucking bellend.
Just
All
walk
right.
into traffic. Go fucking.
No, don't get us. No, we can't get the warning for self-harm. Let's not get the self-harm warning.
Is it there?
No, it hasn't shown up yet, but dude, it's sometimes delayed. But let's see. All right, 5.28 meters of wire. Great. Okay, but now we need. Okay, so the resistivity. Is resistance just resistivity times? Oh, but then it's divided by cross-sectional area, right? Okay. Okay, so resistance is equal to resistivity, I think it's this symbol, times the length, and then it's over A. Okay, so this is 1.1 times 10 to the minus 6 times the 5.28. Thank you, Shush. Yep, times 5.28. Oh, no, wait, it's RA over L. Oh, yeah. Because resistance... No. Resistance should go up with L, and it should go down with A. Oh, I see. Oh, R is your resistance. Sorry, I got it. Sorry, got you. What's the equivalent of PhD in UK? It's just called a PhD. Yeah, it's PhD. Okay, and then this is pi times 0.007 squared. Okay, let's see what we get there. Sorry. Yeah, you're right. You're right, dude. I got you. So 1.1 e to the minus 6 times 5.28 divided by pi. What's my qualification? Yeah, I have more than a master's. Interesting.
That's the point. So just quickly, PhD, is it 3 capital letters because it's an acronym?
I think it's capital P, lowercase h, capital D.
Well, because Hippocratic would be capital H because that's an adjective, isn't it?
Yeah, I get you. But
That's not a noun,
Dr.
it's not a
Philosophy.
noun. Yeah.
Okay, well, we got this wrong.
Good question.
What did I do wrong? What did I do wrong, boys? 18 centimeters of a ceramic cylinder of diameter 1.4. Right? Yeah, okay. And the distance between the wires is 1.5. Kool-Aid Man and Giraffe got some bangers. We probably won't get to them. We're going to run out of time. This is A level? Yeah. I just know I'm not getting the right answer. Alright. Let's see. If I'm not getting the right thing, I want to know what ChatGPT says. I sent a question for you, but it's not visible. Probably because it's in the queue. If you click on Q, you should see it. Don't GPT? Why not? I just want to see what it does. Let's see. Did the Putnam question? What did it get to? Okay, it got something. I'm gonna copy this link. People want to watch it later. Copy the link. What? Why are you taking time to copy? One sec. I use GBT just to see what I'm doing. So, they went for. They didn't even use the. They didn't even do the. Oh my God, this is a completely different way to do it. Oh, see, I mean, this is where GBT is cool. Okay, GPT. I see. They wanted to do it from this. They did it from voltage and power. I did it from all the geometry. Oh, okay, okay. So this is wrong. It's okay. It's how we learn. Wrong. But, okay. You can say from P is equal to IV. And if V is equal to I over R. Or actually, no, because I think I want to keep voltage, right? They tell me the voltage. So I want to say I is equal to V over R. That means P is equal to V squared over R. And they told us the power of this thing. It's a kilowatt. So I'm going to say 1,000 is equal to the voltage, which is 230 volts. Yeah, no, I did too. But apparently it was wrong. See, this is why ChatGPT can help you out. Yeah. Okay. So now you can just do 230 squared. And then just divide it by 1,000. Yeah, duh. You get the right answer. R is 52.9 ohms. You're right. It should work this way. I'm actually really curious. Right? Because the way I see it is like you have like these loops of wire, and you can, if you know the distance between the centers, then that should be the same thing as. I don't know. Let me think about this. Yeah. And if they're the same, right? If you have like two pieces of wire, right? And then you know the distance between the centers. Isn't that kind of a proxy for like what the width of one of the wires is? One of the loops? Right? Because if it's the same loop, the center to the edge is the same as the edge to the center, which is the same as two center to edges, which should just be the width of the loop. I think this method is okay. It just gets a really wrong answer. So it must mean something's wrong with this. Oh, you know what it doesn't take into account?
Oh no.
Yeah, no. Here's where we fucked up. Here, this is wrong.
You done messed up,
This is the area of the wire. I see. Yeah, I was doing the area of the loop.
Oh no.
Yeah, I did the area of the loop. Right? The area of the loop is that, but that's not the area of the wire. Yes. Well, now I see how we're going to do the next part. Because if we know what the resistance is, and I know what this is, now I can solve for the area of the wire. I'm just going to do it, because I'm pretty sure that's the next question. So I can say, okay, 52.9 is equal to rho L over A. I get it now. This is what happened. You know, I mean, we've been streaming for almost 3 hours. I'm gonna make mistakes towards the end. So my brain is frazzled. Okay, there we go. There we go. And then I'm gonna solve for A. And now, right? I'm gonna get that A is equal to. Let's go use a calculator. This is a really cool question, actually. I just misread it at the beginning. Times 5.28, but I understand where they're coming from now. And then we're going to divide that by 52.9. Yeah. Okay, so the area is equal to 1.1 times 10 to the minus 7 meters squared. Let's see, is that given here? Right, okay. So 1.1 times 10 to the minus 7 is the same thing as 0.11 times 10 to the minus 6. So I think the answer is it's going to be 28 gauge wire. We're going to get that from this. Yeah. Yeah. So this is equal to 0.11 times 10 to the minus 6, which is 28 gauge. I think that was the rest of the question, right? Is that what they wanted? Let me go find it. Where did we have your question, sir? Oh, no.
Don't sir me, boy. I work for a living.
Don't sir me, boy. Sir.
There's only two times to say sir. When you're in school and like pre-16, or not post-16, I said. And if you're in the military, don't say sir to me. I'll fucking bray you.
Oh no.
Don't do it. Sensation will get you. Okay. Showing the length of it is 5.3 meters. We did that here. Shush. If you can find that. That's what we did there. And then show that to determine the gauge. That came from this. That's this part. Nice. Cool. Good question. It's fun. Thanks for waiting. I will make some changes to the queue. I don't think we've ever had so many people submit questions regularly to the stream like this. So we always got this in AI. We call this like checking the end cases, or like checking the extremes, like what can break the system. Maybe it's not called end cases. It's called something.
Corner cases.
String cases, maybe?
Are they? Yeah, I feel like there's another thing. I don't know if it's called extreme cases. Maybe.
String cases. Like
String cases. Oh, maybe that's the word.
Yeah, like the ones that could happen, but you don't really worry about. Oh yeah. Jeff,
okay, there we go. Edge cases. That's what I wanted.
Cases.
Or corner cases. Yeah, thank you. Dude, why could I not get that? But by the way,
cases are American. I think I'd say corner cases.
Yeah, corner makes sense. Yeah, too. But Shush, if you want to join the Discord, your question is here, and then there's also the screenshot for it, and there's also the link to where it was on YouTube. So go check that out. Should be fun. All right, let me see. How much time do I got? I got like 13 minutes. Okay, I can do one more. I'm so late. What's up, them? I mean, to be honest, I started the stream an hour early today because I have to go to a friend's thing. Look at all these questions we got. Oh my god, dude, look at this. So many fun ones. Okay. Let's go choose a winner. Who's gonna be next? Hopefully not JE. You're putting
Let's
in.
go gambling.
I need to eat too. I haven't eaten today. Fuck. Ryan!
It's not real one.
Oh, man. I did wake up at 1 o'clock. Okay.
Aw, dang it.
What is this? For P is contained in P... Yeah, okay. I can't do linear maps right now. Thank you for playing, though. I will put that in our Discord for someone to go through. Let's go do
That looks difficult.
It looks
about like the
difficult.
polynomial space of real numbers. And
Yeah, I got
Let's
13
go
minutes left.
gambling.
Someone give me a layup question, please. Gaming God. Okay.
Gaming God. Only
I
plays
think it's
Roblox.
Chem, so I think it is. Oh,
I do like
never mind.
this.
It's not
This
the
is
one.
okay.
It's not Chem.
This is calc. We can do this. Right? We can do this. I feel like this is a root test, no? Determine whether or not 1 to the n to the 1... Oh, wow, that's really fun, actually. All right, so 1 over n to the 1 plus 1 over n converges as n approaches... Isn't this e? Isn't that true? Isn't the limit as n approaches infinity of the summation of 1 plus 1 over n? Oh, to the n. Oh, compare with harmonic series. Okay. Okay. I see.
Yeah, I think this one that might diverge. I'm pretty sure it does.
Well, okay, so we know, right? We know that 1 over n diverges, right? So you have to, if we want to prove this diverges, we have to show that this is greater than this, which I don't think it is. Yeah, and it gets bigger than 1 over 2n at some point, and thus it diverges. It's bigger than 1 over 2n? Okay, let's compare with, so does 1 over 2n? Yeah, good job, Fem. So I need to show that, okay, so if 1 over n to the 1 plus 1 over n is greater than 1 over 2n, then it diverges. Yeah, the limit comparison test, I guess, is what we're doing, right? So, limit as n approaches infinity of this over this. So that's 2n over n to the 1 plus 1 over n. Is there a way to represent this maybe as a series? Because, I mean, I get it, right? As this goes to infinity, this is like 2 times infinity over n over infinity to the 1 plus 1 over infinity. And it's like, this is 0. And so then this limit does go to 2, I guess. But how legal is that in Mathland? Am I allowed to do that?
I think you'd have to use L'Hopital's on
I think we do. Yeah, I do think we do. I do think we do.
1 plus 1 over n.
Yeah, let's do it. Okay.
I believe.
All right, so this is infinity over infinity. So L'Hopital. And in that case, this becomes just 2. So we're going to do ddn of this whole thing. And, well, the top and the bottom. Derivative of the top is just 2. What is the derivative of n to the 1 plus 1 over n? It's
You have
not.
to use your natural log stuff. You gotta take the natural log and exponentiate, and then
Let's do ddx of x to the 1 plus 1 over x. And let's say that's equal to y, right? So, yeah, am I going to take the log of both sides before we do it?
yeah.
Okay. All right, so then this derivative is 1 over x to the 1 plus 1 over x. Oh, wait, no. Sorry, I'm being really dumb. Sorry. Let me pull this down first. Okay. So this is ddx of 1 plus 1 over x times x, right? Or times ln of x is equal to the ln of y. Okay. This is a chain rule. Sorry, a product rule. Derivative of this is negative 1 over x squared times ln of x. And then plus, derivative of this is 1 over x times this. So that's going to be plus 1 over x plus 1 over x squared. And this is equal to the ln of y. So then let's see what we get. So that's 1 over x squared, 1 minus the ln of x, plus 1 over x is equal to ln of y. Let's do e to the...
You gotta exponentiate.
Yeah, let's exponentiate. Okay. So that's e to the 1 over x squared, 1 minus ln of x. Or maybe I should separate it out then, shouldn't I?
Yeah, that'll probably help.
Okay. So that's me e to the 1 over x squared, e to the negative ln of x over x squared, which is the same thing as x to the 1 over x squared. And then e to the, right? E to the negative ln of x is also... Sorry. It's just going to be, fuck. 1 over x to the 1 over x squared. Yeah. And this is equal to y. Oh. Okay. So I get e over x to the 1 over x squared. Oh, which is okay. Right? Because that's equal to y. And as y goes to infinity, this becomes... Did I do this right? Sorry. No, sorry. This negative comes up into the exponent. That comes into here. That's what I do.
Oh, yeah, Fembo made a good point. The 1 over x term. You forgot.
Where did I forget the 1 over x term? Oh, I did.
Plus 1 over x.
Yeah, sorry. I was getting all happy with the other one. Yeah. Okay, so that's e to the 1 over x. So e to the 1 over x times this hot garbage, which is then times e to the ln of x. So this is just x to the negative 1 over x squared, which is the same thing as 1 over x to the 1 over x squared. Right? Okay.
Yeah,
so now that's e to the 1 over x, e over x to the 1 over x squared. Okay. This is 0, but this is also 0. And then this is 0. So I think it just equals 1. Can I say 1 over x squared decreases faster than 1 over x? I think so. So, okay. So I think it's 2 over 1. Answer's 2. Okay, and then so... I'm just going to say it is. Okay, and then by the limit comparison test, it must diverge. Great, congrats. Man, that was a rough one.
You're not that guy.
It looked like it wasn't going to be bad, and then it started getting bad. Fun question, Gaming God. I did appreciate it. You guys have put me through a workout today. It's been a math workout for sure. I appreciate everyone in the chat and stage like helping me get across this finish line. Because, yeah, we still won't get through all these questions. All right. Fuck. I got 1 minute still left. Okay, I will choose a winner. I don't know if I'll be able to do it.
Let's go gambling!
Dog, we have a
I'm
week.
open for Polish giraffe or
Ordinary student, apparently.
Ordinary
Let's see.
student. Lies.
What did ordinary student have? A very long conducting tube is a square cross section. The charge per unit length and longitudinal direction is lambda. Explain why the external electric field diverges at the corners of the tube. Does this result depend on the specific shape? What if the cross section was a hexagon? Or what if the point in question is the tip of a cone or a kink in a wire? Oh. Well, I see there are 3 asterisk signs on it.
Oh, dang it.
Yeah. Yeah. 3-star questions are like no.
Oh no.
I unfortunately won't be able to solve in the next minute. Okay. Yeah. Cool question though. I will leave these in my Discord for other people to go through. Or the bot will go through it. Let me see what else people submitted. Well, yeah, this was an IMO problem.
yeah.
That wasn't going to happen. Man, I could have done this. Yeah, this is easy. This is electric. This is electrochemistry. I like electrochemistry. Kool-Aid Man said, show the differential equation has that as a solution.
What I was talking about earlier with mine, with the Laplace equation, the L acting on U. This is like a textbook example of that. That's y plus a squared acting on y.
Okay. Right, when you take in fundamental theorem of calculus, right? Or is this like a shift? You're going to do a shift here, maybe?
Yeah, that's technically a convolution.
Yeah, okay, cool. All right, that would have been fun. Or Kool-Aid Man is the same? Or no. Oh, double trouble. A ring of mass on its side. A bug of mass m walks around the ring with speed v starting at its pivot. What is the rotational velocity of the ring when a ring? Okay. Oh, this is kind of cool. A bug? I don't know. In how many different ways can the letters of the word Mississippi be arranged if the 4 S's cannot appear consecutively? Oh.
This is actually it's a discrete math problem, and it's actually a really fun problem, but it's not as hard as it seems.
Yeah, I feel like this is like whatever, choose whatever, but then you treat the block of S's as a single block, right?
Yeah, and then you would figure out the total number of ways or permutations that you could do for Mississippi, and then you just subtract your.
So was that 1, 2,
permutations with
3, 4, 5, 6, 7, 8? Yeah, it's just permutations of 8 is all it is.
Yeah, you just subtract the permutations of 8. From
Right,
your
exactly.
total permutations.
Right. Yeah, 11. Yeah, okay, cool. All right, that's not bad. And then Raju, what was yours? A container. Base of it's 2 parallel electric conducting walls. Ring walls are thin. The container is filled with liquid dielectric. Ooh, what is the capacitance? After 10 seconds. Cool. This is. I know this is JEE, right? This is JEE. I recognize this kind of format. It's being filled with a dielectric. Oh, the dielectric is not steady. It's not steady state. Oh, fascinating. Oh, cool. Yeah, I could maybe
Seems
do
like
it.
a really ugly Laplace.
Yeah, it's probably not going to be.
Surprise, motherfucker!
Okay, cool.
Maybe a diffusing equation.
All right, I'm a little bit over time, so let me close out the stream. All right, thank you again, everyone, for coming to Actual Education Office Hours. I appreciate all the questions. We had a lot of really awesome problems today, yeah, and some other awesome ones that are still left in the queue. So yeah, I stream I give you guys 3 hours of my day, but I can't give you any more because I have other things I have to do. But that being said, if you submit a question and we didn't get to it, go to actualofficehours.com, this website, and then if you click on join our Discord, all the questions we didn't get to today will get thrown into our Discord, into the homework help channel. And then inside there, we have other people that'll work on them, or I have like a bot that'll go through every 2 days and like try to do stuff, or at least give you some hints. You know, AI can be really helpful for like getting you started. So also while you're there, click on the streaming schedule. That shows all the times that everyone, not everyone, but a lot of our awesome math and science streamers are streaming. So our next stream tomorrow, we're gonna have a chess tournament. So come on by to the chess tournament. It's gonna be on Friday, tomorrow at 6 o'clock Pacific. And then Saturday, awesome day. We got Zach in the morning. We got Math Pod in the afternoon. We got math trivia. And then we also have Penn doing, I want to say this is some sort of video game he's playing. So yeah, and you can click on any of these accounts and it'll show their channel. So make sure, go follow them. Or I guess this, oh, I know why this isn't working. It's because Penn Center put all his usernames in one. Yeah, if they put in the calendar just their username, it'll show this up. Okay, cool. All right, and then yeah, make sure go follow us on Twitch. It's the best place to see all the other people, and we have a nice community and all sorts of fun stuff. And I have a lot of great friends, and I'm really thankful. And we're gonna go raid somebody, and then I'm gonna go eat for the first time today. Right, let's see. We're gonna go say hi to.
First time, eat more beef, you skinny bastard.
I know, dude. I woke up at 1 p.m. today, man. My sleep schedule's fucked, dude. It's so bad. Right.
Get yourself a sausage sarnie.
I need to go to Greg's, dude, and get myself a sausage roll.
Fucking Thomas the Baker's is so much better.
Nice. Let's go say hi to Nerduino. Nerduino's great. He's doing something. Oh, the Artemis mission? Yeah, great. Awesome. Cool. Okay. I know, I didn't solve it. I didn't have time. But my apologies. Go have fun. Say hi to Nerduino. Enjoy the rest of your week. We'll see you Friday for chess. Otherwise, we'll see you on Saturday for trivia. Otherwise, we'll see you Sunday for homework. Peace.
Actual education. Welcome in. Raiders, welcome. How you doing, Actual Education? Guys, make sure you're following Actual Education. How's it going? How was your stream?